Let's say he wrote about 1950. So, everybody, good morning and welcome to the MariaDB Day here. We had a bit of a discussion what we would call the day, because there are 3 FOSDEM days on Thursday and Friday that others organize, and we were thinking of calling this 3 FOSDEM days, which is close to FOSDEM. We are close to FOSDEM here, and we don't want to compete with FOSDEM, but we also want to capitalize on the fact that there are many brilliant minds around focusing on MariaDB here, and we want to use that time for 2 things. One is to spread information, but also, as you will see later today, a bit to collect information. So we have a panel where we are going to ask you more than tell you things. And a great source for presentations today has been the submissions to the MySQL MariaDB and Friends dev room, and there were 77 submissions we heard, and the number of slots was much lower than that. So of course we're really happy to have so many presenters of those 77 that didn't fit into the slot of 13. But first we'll have somebody who did fit into the dev room yesterday. So that's Peter. He's not going to give a repeat of yesterday's presentation. It's about, or we'll observe what it's about.
Yes, you will.
If I might, some practical announcements.
Yes, please.
So, hello everyone. First of all, we have some amazing stylish merchandise, top of fashion. If you haven't helped yourself to those yet, please do. Second, we have some tea, coffee, and cookies and candies with alcohol. Also, please enjoy. And third, for those who present, we have a large screen and camera going on. So please position yourself somehow that you are within the camera range.
I think it's possible.
Yes. So maybe don't dance around the stage and such just yet.
No, too much.
Okay. Oh, we have something. I was saying like, hey, plug in and nothing happens, and it's actually you just have to wait for a few seconds, and maybe something happens. Hello. Okay. Once again. No, something doesn't happen. Okay. You know, you should blame Monty. He told me you should never run Windows. Right, Monty?
No.
No? Oh, okay, I see. That's right, well. Give me 1 second, I have to figure out why. No, I mean, it's very funny. I mean, now it's my stupid.
If you are using Windows, you can use Scala.
No, I mean, it's not a problem. The problem is now it doesn't, my PowerPoint seems to have died, so I need to do some little killing thing and then.
Maybe we can start the video and then use PDF URL.
What's that? I don't know what's that. I think
They want to name my Linux laptop over.
no pressure, Marty, no pressure. Like, come on. Come on.
You are on live video, so no stress.
No stress, no stress. Oh, I think I have an idea. Okay, I have an idea. Okay, that's, yes, probably Indian, yes, I think that's why. It turns out that I think it's a user error. My laptop is smart enough to disable trackpad when I have an external mouse, which turned on automatically in my laptop, right? You see? It's, you know.
Sounds like a Windows laptop.
Oh yes, exactly. They're just too smart, so you don't. So like, why come my mouse is not fucking clicking? And that's exactly why. Because it's trying to protect myself from myself. That's what Windows does. And it's typically not a bad thing to do, but in this case, that's because a panic and almost gives me a heart attack, right? Well, anyway. Should I use a microphone? Do you guys use for recording? No? No? Okay, then I want to think you don't need that. I will talk today about the MariaDB observability. And before that, the guy was talking about how this day should be called. I think the day today should be called the Palindrome Day. So you can call it Palindrome MariaDB Day because, you know, you can see these digits on top. Forward and backwards, they read the same, right? Which is a very unique event, I think, especially in this kind of full form. Okay, so why are we talking about the observability today, right? If you look at running the database systems in production, you of course have a lot of complicated problems. Many of them are not easily repeatable, right? In my experience, if you have a bug, we can say, hey, you know what, the development team can easily repeat it, and that is probably, you know, half a year or more of fixing that bug, right? Especially if you look at some more complicated things, you know, contentions, things which happen in the distributed system, and so on and so forth, right? And really, to troubleshoot those things, efficiency bugs, performance problems, and what's not, you really need to have insights in terms of what is going on in the system, and that is what observability is all about. Now, when I look about observability, I kind of look about the two approaches, right? Two things which we need to do. One is something what we are having ongoing data capture as a monitoring, right? We capture the data all the time, day in, day out, and we store it somewhere. That is used for monitoring. The thing in this case is, of course, their overhead of that activity should be relatively low, right? The other is when we do some of the more temporary data capture, which we do for debugging. Let's say you have something which is going wrong, right? You connect to the system, start to debug it. In this case, often we can deal with high data volumes, more overhead, and so on and so forth, right? If that helps us to troubleshoot the problem. Now, what I think is interesting in this case is also, if I look at the database system, right, as MariaDB, you can't really just look at the MariaDB alone, especially when it comes to the performance problems, right? Because operating system problems, hardware can be often the root cause. Application issues, what application is doing, also cannot be ignored. In very many cases, we hear from users, they say, oh, you know what, everything is the same as it was yesterday, by now it's craps out. Yeah, and when you take a look at that, actually somebody pushed a new code, right, or, you know, something else happened, their application behavior drastically changes and they blame the database. Well, because guess what, that's what developers do, right? And also there are some other, I think, important concepts, especially if you work in increasingly popular virtualized and cloud environments, right? You know, noisy neighbors, some other background load, because you cannot really, in this case, focus only what's going on your system, on your OS image, but you have to look at those other things as well. Okay, with that little preview, let's look at specifically what MariaDB has to offer in terms of observability, right? And as I have a relatively short slot, I will only cover most important things and relatively high level of details. So as of MariaDB 10.4, I think these are the main key data sources, right? If you are looking to build an observability system, try to evaluate an observability system which you can use when it comes to MariaDB. Show status or show global status. That is something which is like existed forever, right? I don't remember any version of MySQL that didn't have show status, right? It has in MariaDB more than 500 variables, so there's a lot of information available out there. Most of them are counters, some of them are kind of gadgets, you know, show a current value, right? Threads running, and some of them may contain some, you know, text information. Also, this shows status that have a session and a global scope, right? So you can take a look at the value which is global for a session itself, or you can, for the whole server, or you can take a look at what the values are for your current service. What is also interesting is that this data is also available as an information schema table, right? If you prefer to use SQL syntax select rather than show syntax. Okay. Something I think it's interesting to point out here is what in in MariaDB, it's available in information schema, and this is different in MySQL, which move those tables to performance schema, right? This is how it works, right? If you use an SQL syntax, for example, right, we can get a number of questions, right, which is number of queries the system handled. You can see that globally there was a lot of queries, right? Obviously, when I look at the session status, that is how many queries my session did, that is a lot lower. Now, I think what is interesting in this case is to note what are really truly session variables, right? So specifically, if you look at the rows information, right, you query session variables, the data is presented, but that is actually the global values. That is not the local values for a session, right? So there is a little bit of a disconnect, right, and there is no easy way I know, right, to detect which is truly session variables which I display the session. And that is kind of a hard problem because that sort of came from, you know, MySQL behavior from ages and ages ago, right, which was never wrong. If you are looking to get something like stats-like output, you can use MariaDB admin or MySQL admin, right, to get such output. If you look here, the what's happened here? Yeah, the first value. This is so from the start of the system, and then these kind of correspond to an increment, right? So in this case, it corresponds to just 1 second. Okay, moving on to information schema. In an information schema for MariaDB, there are more than 70 tables. Many of them contain information about the schema and other data objects which exist in MySQL. There are others which are information related, right? This is, for example, what you can see about their table information, right? There are a lot of helpful data to understand, you know, space usage by different storage engine, right, and so on and so forth, right? And there are also data such as MariaDB metrics, which contains the performance data. Now, if you look at the MariaDB metrics, and if you look at the observability for MariaDB storage engine in particular, it contains a lot of very interesting data, right? Especially helpful to troubleshoot some complicated problems, right? And it looks very similar in to show status, but important difference is what many of the variables are not enabled by default, right? So, yeah, you got a question?
Performance impact you enable by default?
Yeah, that is a good question. Actually, this is very low, right? I mean, I have been enabled by default. It's you know, doesn't seem to have, you know, fractional percent, right, overhead. So it's not like performance schema where the overhead can be quite large.
So why not enable it by default MariaDB?
Well, I'm just saying it's how it is, right? I think some of that is also, in many cases, MySQL and MariaDB, they both provide so much information by default for conventional user, it is kind of too much, right? And in this case, you don't enable by default what most users would.
They are there, they are just set by to 0. So,
yeah. But anyway, so if you want this data, you'll have to enable it, right? And I think it's interesting also in this case. It has some other interesting things, right? You can see it stores a mix and max value, right, and some others. Oh, look at that! It looks like some more food came in.
Is that the case?
Hey, David. Okay. Another thing which exists in MariaDB in information schema is this MariaDB utilities table. right? Which is pretty cool because while you can enable to get the mutex information in information schema, in performance schema, it has a very high overhead. You can also get some status from show in the DB status, but that is not parsable, right? So I really like what this is accessible, right, through select in MariaDB. It's not accessible in MySQL. What is interesting in this case, and what was surprising in MariaDB 4, what the name is empty. I was surprised because the documentation, it actually shows this table with a name in it, which is actually cool, right? Because this, if you look at the create file and create line, obviously these are not stable, right? Between this minor version, they can change if the code was changed, while the variable names, if it's defined, it is much more stable. Also, MariaDB has an extended process list, which is available in the information schema table. And I think what is very cool and practical things in the process list, but you can see the progress report here. You can also see amount of memory and max memory used, which is often very, very helpful, right? Often you can see some very tiny folks asking, okay, you know, what the hell is uses a lot of memory? You can see that very easily and simply in MariaDB this way. Moving on to performance schema. Performance schema contains some of the most advanced instrumentation available. It has more than 50 tables, but the thing to know, it is disabled by default in MariaDB 10.4, and to enable that you need to restart your server, right? So that's not something you enable online. Depending on how you enable performance schema, the overhead can be going quite high, right? You can, typical configuration, is a few %, but you can get 10% or more depending on what you enable and how you configure it. So if you look at performance schema configuration, it is, I think, very distinct from many other items in MySQL, right? How you configure. It's done through performance schema tables, right? So it can be done at runtime with SQL. There you also can do that through configuration settings. Setup actors tells us what kind of users are going to be monitored, right? Then you can set up consumers, which tell us about what kind of summaries are going to be built, right? And these are default settings. And then you also can go and enable and disable specific instrumentation points in the code. So MariaDB contains more than 700 instrumentation points, and more than 250 of them are enabled, right? So that means is about 1/3 of instrumentation points are enabled by default, whereas they're disabled, probably because of the high overhead enable them codes, right, compared to the value they provide. And I think the configuration is you can also configure what objects you want to instrument, right? So if you can see the default, in case it's enabled, we do not instrument MySQL performance schema, right, and the information schema in this setup. So here is example of what performance schema can provide, right? And you can see there is a lot of information, right, which is shows us about the current state and running. You can see a lot of this information is not super user-friendly, right? You can see that timer start, timer end, those things are kind of measured in picoseconds. Anybody knows how many zeros, right? But how much you kind of divide, right, to get the real seconds? Yeah. What's that?
5 zeros.
Yes. There is always one smart one in the room. But anyway, I mean that is kind of hard, right? And in MySQL there is a C schema included to convert those more human readable values. MariaDB currently does not include. Right. Here's another example which shows one of the summary in this case for file IO summary, right? We can see for MariaDB data file here, right? We can see the number of IOs, right? Number of reads, number of writes, number of other stuff which corresponds to MISC really corresponds to fsync, right? And the time which it took to serve those requests. Which is again, if you can convert them from picoseconds, actually is quite interesting information. Okay, logs. Obviously, logs are also very valuable information, which you can get with MariaDB. You can have error log, general query log, slow query log. I will, for the sake of time, focus on the slow query log here to show what MariaDB has to offer. Right, this is how default MariaDB slow query log looks like. Right, you can see there is query information again, as well as some execution statistics available here. One of the very cool features what MariaDB has, which MySQL, for example, doesn't, is you can also enable the explain class to be stored in the slow query log, which is especially helpful if you use slow query log for all the queries, right? You set the long query time to some high value, and then if the query goes slow, you can see explain plan right there in the explain log why it was slow. Why is that important? Because sometimes the execution plans would not be stable, right? There may be something weird with that particular query execution, and if you run the query again from command line, you might not get the same explain plan. Yeah, I had a big question.
Maybe I did not listen well. Is it enabled by default?
No, that's not enabled by default, right? There is, there's slow query log settings where you can configure to write it. So this is kind of how default looks, and then you can add the explain. Yeah, Manti, did you want to comment?
You guys said you have lots of options. You actually take something from a coin server, like you can configure. For example, if you're running a store procedure, you can either have a store procedure as one unit or every row as a separate unit.
Yeah, I mean, there is a lot of stuff. Again, for sake of time, 20 minutes, I thought I would focus on something which many of you may not know about, or I will find especially interesting. Okay. No, it's going to the wrong direction. So the next thing I'll cover is explain. That is, and I think obviously any DBA or developer should know. Well, most developers don't, right? If you look at the grand scheme of things, right? Which is really cool to understand why the queries are running slow, right? Now, here is some simple explain example, right, for MariaDB, and there are some advanced cool features MariaDB has. You can use explain with format equals JSON, which gives you information in JSON format with more data, and I think it's kind of more machine parsable, right? So if you want to run some script to say, hey, I want to parse explain for my queries, and there's like some things I don't like, then explain format equals JSON is absolutely fantastic. You also have a show explain for connection ID, right? That is fantastic for the queries which are currently running, right? If you have a query which is running for 3 hours and you say, what the hell is going on, right? Of course, you can just kill it, but you probably want to understand why this particular instance of query is running slow before you kill it, and that is a fantastic way to do that. There is also an analyze statement in MariaDB, which also was known as explain. Analyze in some early versions, which allow us to actually run the query and see how the actual execution compares to what explain shows, right? This is how it looks for this query, and you can see what explain is estimated for the first table. There is kind of this number of rows, that is actual number of rows, right? This was kind of estimated, again, column matches from, and methods, in this case it's even 100% match, and you can see for the second table, rows number estimated was this number, right? And this was the number of rows which is actually found in the process, right? You can see in this case the numbers are pretty close, right? In some cases, in different queries you may have your explained results and the kind of actual execution maybe well off, and that's kind of signaling, for example, hey, you know what, I need to update my stats, right? Or maybe there's something else which is different. Well, and let me end this presentation with a shameless plug. So if you guys are looking for some observability solution for databases, the open source one, we have a tool which is called Perform Monitor Management, which I think most of you know already, which has a special focus of really helping to aggregate and analyze queries from large number of servers over, over a period of time. So if you haven't, check it out, you may like it. And that's it for me. Thank you.
Thank you, Peter. We'll continue seamlessly between the ones. Now we have Andrew next. Let's see how connectivity works for you.
That's not so pretty. You have to add to every single column file in the system. So that can be a little more painful to deal with. We have ways around that with MariaDB console, which I'll talk about in a little bit. But that can be a performance penalty. Updates, though, are a little bit easier. Unfortunately, colors didn't quite come out here. But if you wanted to update, say, the age column, a value in the age column, for a row-based system, you would have to rewrite the whole row, or old row, append a new row, something like that. For a column-based system, you literally just have to update the column file. So it makes things a little bit simpler for updates. Then deletes again get a bit more painful because you have to delete every single item from every single column that is involved. And again, there are ways around this. You can do things like partitioning and just drop an entire partition, all sorts of things like that. If you want to change the table structure, adding a column, deleting a column, this becomes almost an atomic operation because you're literally just adding a file, deleting a file, instead of rewriting out the entire table. There are several workarounds for this. I know in MariaDB, but this becomes a much simpler operation. So why use it? Basically, MariaDB Store is designed to deal with very, very large data sets, especially when you want to do large amounts of aggregation or large amounts of filtering. It's optimized for star schema in particular, so we use hash joins, etc. And we actually have very rapid bulk data insertion rates. Traditional OLTP, smaller data sets, kind of typically you'd use less than a terabyte. More basic queries, if you had like very large joins or very, very large aggregates, you tend to get quite slow. You'd have to have large indexes and things. And if you had lots of DML queries, OLTP is a lot better for that kind of thing, whereas columnar storage is better for more data warehousing, archival, that kind of thing. So one particular customer we have at 3 Corporation is IHME. They actually have the health data, and in fact death records for millions and millions of people all over the planet. And they use this to work out trends on various illnesses and various things going on like that. You can actually go to their website right now. If you just Google search for IHME, you can see it. The website is actually live generated from a MariaDB Store instance, and you can view health maps, all sorts of interesting visualizations like that. So a little bit more about MariaDB Store. It started in 2010 as a product called InfinityDB, and InfinityDB before that was actually an appliance-based system. They turned it into software, essentially. Calpont, the company who created it, was called InfinityDB. Unfortunately, they closed down, and SkySQL at the time was just going through transition to being called MariaDB. we kind of said we're going to support the InfinityB customers. But there were so many patches and things that we were kind of building onto this to fix bugs for customers that we decided to create our own product. So we call it MariaDB Column Store. Later that year, I joined and jumped straight onto the Column Store project. I started as a senior engineer and went all the way up. December 2016, we launched our first GA, which was kind of InfinityB with MariaDB 10.1, lots of bug fixes and several improvements. 10.2, we had, with MariaDB Column Store 1.1, we had APIs for bulk writing, so you could write in C, Python, Java, a few other things directly into Column Store. We had even more kind of improvements. Then our 1.2 release was massive. It used MariaDB 10.3. We had the time data type, which we never had before, microsecond support, user-defined analytical functions, both in MariaDB and in Column Store. And lots of extra features like that. And last month we finally got to the point where we could actually bundle Column Store with MariaDB. We've done this with MariaDB Enterprise to start with, because our release schedules didn't quite align for MariaDB Community Edition. So before this we had a fork in MariaDB because we had to kind of lie to the optimizer about certain things. We were working with the MariaDB server team to have special handler calls, so we could get rid of all of this extra code we were bundling on to MariaDB to make this work. So MariaDB Enterprise 10.4 now includes Column Store 1.4, so we've got what we call convergence for this. We've got a few more data types. We've got S3 storage backend, so you can effectively use Amazon S3 for cheaper storage with a small cache locally, and many performance improvements. So Column Store 1.2 uses a fork of MariaDB 10.3. 1.4 is included in MariaDB Enterprise 10.4, and it can be built on MariaDB Community 10.4. I will send out instructions on the mailing list on how to do this. I haven't got around to that yet because we've been so busy with the release itself. 1.5, which we're working on right now, is intended to be included with the Community and Enterprise edition of MariaDB. There is actually a pull request to do this right now. I think there's a few things we need to clean up first before it actually gets merged, so it may not make it to the beta release of 10.5, but it's very soon to be included. So, the things to make things a lot faster with Column Store, we've got this thing called extended elimination. So each column is broken up into 8 million row, or 8 million items of data, and there's metadata going on with it to store the minimum and maximum values of that 8 million rows. So if we've got a query here, select item, some quantity from orders where ship dates between 2 dates, group by item. We can see straight away extent 1 is within those dates, so yeah, we're going to query that. Extent 2, that date range isn't there, and extent 3, that date range isn't there. So before we even ask the database if there's anything, the metadata just eliminates those straight away, so we're not even reading that data. And then we only care about those 3 columns. So those are the only 3 column files we're actually going to read from the disk or from our LIU cache. So if you've got a huge amount of data here, we've eliminated it down to 3 8 million row files. So it's a great way of eliminating huge amounts of data down into very small result sets. Column Store is massively parallel. So we have these concepts of user modules and performance modules. They are terribly named, but there have been lots of debates on renaming this, and we never got around to it. So essentially, a user module is MariaDB server and a plugin and a few extra processes. What this will do is break up a query into lots of primitive job steps. So a join would be a primitive job step, and then aggregate and so on. These are all chained together. These are sent to performance modules, which actually know about their own data. There's a shared nothing storage below it. So a join would be, a basic query would be broken up to query all the extents individually. So basically, a single query can use all the processors on every node simultaneously. This does mean if you're running like 20 queries at once, you're going to find a performance impact on those queries because every query is trying to use all the resources of the system at the same time. But it does mean that we can scan data extremely fast. So to make sure that everything lines up, we have fixed width columns, 1 byte, 2 byte, 4 byte, 8 byte. We're working on larger columns so we can deal with larger decimal formats, etc. For anything bigger than 8 byte, we have a concept of a dictionary structure. So we've got essentially an 8 byte pointer and a kind of flat file just full of data, so the pointer points to where the data is. So if we are var chars, blobs, etc., those go in the dictionary file. And this means that we can very easily figure out with some basic maths, say for row 3, that's a 2 byte field, we know straight away where, on 4 byte field, where the extra part of row 3 would be. It's quite a simple way of doing big calculations there. So the extent map, this metadata I was talking about, contains an object ID, so every column, dictionary file, etc. is an object. Table also has an object ID. The object type, we use logical block IDs where everything's on a kilobyte block level. So the start and the end of a given extent. The minimum value and the maximum value stored in that extent. For instance, this is easy to figure out. Bar charts and stuff, it's usually the first 8 bytes. The width of the column itself. The DB root, is essentially a partition. You can have multiple partitions per node. And then we've got a partition ID, second ID, and offset. This is essentially figuring out the extent number and the file name. And then we've got a concept called a high watermark. Now this is quite useful for bulk inserts. Essentially what it is, it's a pointer to the end of the file to be read. So when we do bulk inserts, we just append data onto the extents, add new extents, etc. On commit, we move this high watermark and say, this is where the end of the file is now. On a rollback, we don't move it. So it makes it a lot easier to figure out where the end of the data actually is, which means essentially we are recommitted isolation level. So the disk storage, we have the extent, which is 8 rows, so 8 megabytes to 64 megabyte. The segment file contains 2 extents for some reason. That's just the way MariaDB did it, we haven't changed that. It's compressed into 4 megabyte chunks using snappy compression, and inside that there are the 8 kilobyte blocks. So it can compress down very, very well, especially if you've got quite a lot of sequential data in the column. We use hash joins, so it's great for equality joins, not so great if you're not doing equality joins. No indexes are constant whatsoever. Try and add a primary key, you'll get an error. Basically, extent map elimination is our equivalent of an index. So since you've got these column files, these extent files, they're essentially our indexes in themselves, so that we don't really support indexes. Multi-threaded joins, multi-threaded aggregates. People keep saying that MariaDB needs multi-threaded, well, we already have it. Bulk writes, we've got a tool called CP import, which reads pure CSV. We support load data in file, insert select, all of that kind of stuff. And that's all very fast. DML writes in Constor are very slow at the moment. We use a concept of an undo log, which means that every time you change a column, we have to copy the old block into the undo log, sync it, write the new data into the new column, sync it, and this can be an extremely slow process. Especially since a lot of the data is local, so you've got network hops there as well going on. And every query is going to try and use every core on the system. We have a concept. Oh, sorry, yeah.
So let's say you have 4 worker nodes with 4 cores. That means one query will use 16 cores?
Yes.
Well,
yeah, assuming the data is on all spread across all the nodes, will you try and use all 16 cores for the query?
And
Yeah.
you mentioned to use Snappy, right, for compression. Is that the only compression support, or do you use like different ones?
It's the only one supported at the moment. We are looking, it's just, the question is just Snappy compression, unit compression. It's the only one at the moment. If MariaDB had another one which was proprietary, so we had to remove that. It is very easy for us to add another compression algorithm. We're looking at LZ4, for example.
Yeah, I was wondering, because I think LZ4 has been sort of like a better easy side.
Yeah, exactly. LZ4 is really looking really good recently. So.
And then you said you have extended elimination, right?
Yeah.
In this case. So you can extend, do you have a data sorted in any way, or is it
No, data is not sorted. It's natural order that the data goes into.
Okay, so I see. And then for extended elimination, do you have any
Blue filters.
blue filters, right, or whatever other tools?
We don't have blue filters yet. Again, that's something we're looking into. In particular for the dictionary.
Yeah, well, I think like there's also tools like we have like a mix and max value, right? So you can skip that value, so you don't have that filter.
We only got the min and max to filter on at the moment.
Was that
We've only got the min and max values. to
on
filter.
every column, right?
Sorry?
On every column.
On every extent of every column.
Yeah, on every extent
row.
on
Yeah.
I see. So that's kind of okay.
Yeah.
On the query, can you define the number of parallelism, or is the intention to run just one query at a time in the whole cluster?
So the question is, can you find the parallelism? You can, but it's very difficult because we have a concept of a thread pool, and it just basically tries to consume the thread pool. So there are some settings you can change, but you would have to restart the entire cluster every time you change your settings.
Okay, so not like or have to select parallel 4 or something like that.
No, but you can change the priority of the query. Honestly, I can't remember how to do that because it's been so long since anyone's asked how to do that. But you can make some queries higher priority than others inside the system, and they will get high priority in the thread pool.
So the typical pattern is not to run too many queries at the same time.
Exactly, don't want to run too many queries at the same time.
Okay.
And in fact, if you try to run more than 20 queries at once, it will start stacking them up.
Yeah.
Because it's just too many threads running at the same time. Because if you think about how we work, so you've just got a simple select and aware condition, and so you've got, say, 50 odd extents. It will break that up into 50 jobs to be run in parallel. And that's just with a simple select. You then got, so you've got hash join or something like that as well. That then breaks it up into more pipeline jobs. We create hash buckets based on the number of cores, and then that's going on. And then aggregates again, we have buckets for aggregation. So all of this is happening. And then we pipeline everything as well. We've got FIFO buffers between every step. So all these steps can run in parallel, one feeding into the next step. So there's parallelization going on in lots of different forms.
Do you have a recommendation of size of data set where it starts making sense?
Size-based where it starts making sense.
Terabyte or up?
I would say hundreds of gigabytes where it starts making sense, definitely. We can run on a gigabyte of data, but MariaDB would probably be faster. So,
Sure.
But yeah, in our tests we use like a gigabyte of data when I'm demoing on small systems. You kind of need a lot of cores and a lot of RAM really for this, so that we can cache a lot of data. And also joins and aggregates execute in memory, so the more RAM you have, the better for that. We can split onto disk for joins, we can't yet for aggregates. So it's best to have a lot of RAM in both the UM and the PM. The UM and PM can be on the same physical system, and you can run it on one single machine. In fact, we do this in SkySQL right now.
Let me go also like this one. You get the CPU and memory for other machine. So if you are running in a DB for doing a lot of stuff, you don't want to flush the buffer pool just because you want to migrate. So in this case, I columns on a single server and run that, it will be much faster.
Yeah. Basically, yeah. More RAM you can give it, the faster it will go, basically.
And then you mentioned what you have in memory, which can spill out for some until tune what is max memory, or is it just
For spill to disk?
No, you say there's certain things you cannot be spilled.
Yes, yeah. So yeah, we have it looks by default. It looks at how much system RAM there is and allocates a percentage of that as the maximum amount of RAM. So for the PMs, it'll actually use that as a bit like the NMD buffer pool, you know, the maximum.
So it's optimized, and is it shared? Is it shared by all queries or just one? Is it per query?
Shared by all queries.
Okay, so it's not like it's MySQL, it's sort buffer size.
No. It's yeah. We've got this accounting system to make sure that you don't overflow that kind of memory too much. It doesn't include network buffers though, so we don't let you set the percentage to 100% because then you won't have any space left for network buffer. But it's still a good way of kind of publishing the system. It figures out if you've got U and PM combined, it will give, say, 50% of the RAM to the LIU, 25% of the RAM to aggregates and joins, and then you've got 25% for, say, MariaDB and everything else running on the system. By default, you can change all this quite easily, and you can get fixed numbers. So if you're running on Kubernetes, for example, it can lie about how much RAM you have in the system. So we support fixed numbers as well for that. So cross-engine joins is a system that's kind of unique to Coldstore. If you want to join with an MariaDB table, we actually do this inside Coldstore rather than inside MariaDB server. We do this by making a connection back to MariaDB and querying for the MariaDB data, and then it runs it through our hash join algorithm. So it's designed for using small pivot tables inside MariaDB, where data could change quite a lot. And essentially it's running from a local process, loops like that. It's probably not the best way of doing things, but it's pretty efficient, yes.
Network recommendation, 1 gigabit plus, 10 gigabit?
10 gigabit preferably, yes, for network.
And you say it's going to be merged in MariaDB 10.5?
Yes.
Right? And in this case, does it mean it will use the same parser, right? So it will be complete syntax compatibility, or is it going to essentially, steal it?
So, yeah, we do use MariaDB's parser. We support a lot of the syntax. There's certain data types that Coldstore doesn't support, and you'll get an error if you try and use those. We have our own DDL parser right now. So DDL essentially gets reparsed because there's some special syntax to change per column compression and things like that. But that will all go away eventually. Probably not for 10.5, but...
What I mean more is for select.
Select, yeah.
Right, so wherever it will be like advanced CTE functions, right, or let's say some built-in functions which MariaDB 10.5 has, all of those.
It will all definitely pass, but things that we can't support internally will error saying we can't support them. So we support CTEs, for example. We don't support recursive CTEs. So if you try to do recursive CTE, our engine would say, sorry, we don't know how to do it.
I see. So they will, you'll get reasonable error. So not everything will support it, but you'll get an error message.
Exactly, yeah.
But if you do that in upper level, if you don't support it.
We don't do the upper level yet, no. Not for that one, not for CTEs.
You can do it for that, in other cases.
Some other cases, yeah. Function, passing.
So the idea here is that if we first pass to the upper level, then the Coldstore will send the query to the Coldstore, which can say, can I do that or not?
Okay.
And then if you can do it, it does it. If not, the upper level should do it. It doesn't know why the unit functions is not doing that.
Yeah, but I think in some cases, I think that's, I've seen that implementation 77 in flat, right? Because if you look at upper level do that, it's kind of, nested loops on the column store, you better not do it, right?
So if there's anything we say, we can't support, we have this thing called a select handler. It's quite new in MariaDB. You can turn the select handler off, and then it will use Coldstore as a basic engine, just doing the read row event. That is extremely slow. we don't recommend doing that.
That's
But
it.
if you really
That's
need
it.
to see
In
how
any
it
case,
works.
you would rather get an error
Yeah.
instead of use something.
Exactly. So by default, you'll get an error. You can switch it back into slow mode, and it will actually.
Okay, good.
But yeah. So there are certain basically every function MariaDB has, we have to re-implement because they have executing the PM nodes. So if there's a function we have re-implemented, like some of the JSON functions, you would get an error, things like that. So yeah, that's everything I had. Megworks 2020, I've got a slide for that for some reason. And that's it. Thank you very much.
Thank you, Andrew. So, do we have the schedule somewhere for everybody to see, or who's up next? Ah, so it's Seppo. Yes, you are there. Good. And then Nikita after Seppo, just to prepare. So silly to have broken. Okay.
Alright, welcome to the third presentation. It's about Cholera. We are running a bit late, and the slot is quite tight, 20 minutes. I cut out a couple of slides, and this is a general overview of all Cholera features that we as a codership have planned to put in the MariaDB 10.5. Just short introduction, maybe everybody knows me already. I'm Seppo Jaakola from Codership. We started to work on MySQL maybe 15 years ago, and now focusing more and more on MariaDB side. This our team, we started with 3 people, only me, Teemu, Alexei, but now we have grown a lot bigger, so building a database cluster is not that simple that you can handle with 3 people. The headcount today in our company is 17, and for counting all the part-timers and full-timers in that number. For Maria 10.5, 7 developers have participated in engineering for the work. For this presentation, there's just a short overview of the major features that we are pushing for MariaDB 10.5. This release obviously is not yet out, it's just in the planning stage, and there will be 2 versions. There's an enterprise version and then a community version. And we as a codership, we just push these Cholera features, and then MariaDB Corporation next division which goes to which release. Here are the major releases: GTID consistency. I will have only one slide about that, just a brief overview. Then cluster error blocking, XA transactions in a cluster. These are in the pipeline for community edition at the moment, and non-blocking DDL and black box, which is quite new feature, are currently in the pipeline for enterprise server version. I will briefly talk about all these in a high level. The same presentation, I submit a proposal for the Open 2020, and we should extend for that conference if I get to talk in that conference. GTID compatibility has been a problem for Cholera MariaDB versions during all times because of the difference of the GTID format in MariaDB. There is domain ID, server ID, and then a sequence number, so it has 3 elements. In the Cholera side, we have a GTID as well, but it's just a UUID, the cluster, and then the sequence number of the replicated writes, and we have to make these compatible. With this work, it started for 10.5 focus, but it was then backported to 10.4, and it's already merged in the forthcoming 10.4 releases, so it should be there as well. What it will guarantee is that the end user will always see the MariaDB format, GTID, and you can see it if you have a MariaDB master. You can see your transaction in the bin logs in a Cholera cluster with the same GTID, so you can catch your point in there. Cholera itself uses internally the Cholera GTID, and that's the GTID that we record, for example, in the MariaDB rollback segment. So if a transaction that is committed, we can find that Cholera has committed this transaction with this Cholera GTID. This feature was developed by Mario practically alone from our team. Cluster error voting is the next one. It's designed and implemented totally by Alexei Yurchenko. In principle, it's a protocol for cluster nodes to decide that how they will react to errors in replication. Here's a short animation. I started to play with the LibreOffice animations. I hope nothing breaks in my presentation here, but here is a final cluster. If there's a transaction hitting to the first node in a cluster, it's in a commit phase. When you commit a transaction, then Color will replicate the transactions. So you can see that the transaction will be present in every node practically at the same time, with a little bit of time lag, of course. And then we keep, because cluster has accepted this transaction, it will give OK status to the client. Client is happy that my transaction is committed, and the cluster is digesting it. And it's still digesting, but it may turn out that some of the nodes, one or two, may have problem in applying of the rights for some reason. The most obvious reason is data inconsistency. For example, if you have a different data contents in some table, and a transaction wants to modify data in this table, it cannot find a row, it cannot do anything. The current behavior of color cluster is then just to abort the node. So this is not a good node to use, and therefore it aborts. And it has been a problem because it could be that the troublemaker was actually the originating node, the first node. Maybe it had a one row too much that nobody else in the cluster had, and then you wanted to delete that row, and then every other node will see that, okay, I cannot delete this row because it doesn't exist, therefore I abort, and then you lose your whole cluster. But with cluster error voting, now two nodes in this cluster, they saw the error, so something explodes in these nodes. What happens, the first node that knows that I cannot digest this incoming writes, therefore I start error voting. There's a new protocol for it, the red arrows in the replication channel, so the nodes start to discuss that. The first node tells that I tried to apply this right set and I got this error. And then every node must respond to that. They tell that when I applied this transaction, I got success, and the other node, the node number 4 in this animation tells that, oh, I failed to also with this error, and then these two nodes see that we failed with the same error, and the 3 nodes see that I got no errors. And then the result of the error voting is that 2 of the nodes will go out. If my animation works okay, works. So as a result, there is a failure cluster. With earlier Java versions, it could be that the whole cluster is gone, depending on the scenario that you have. So it looks good, but it's not that good actually, because all this is post-mortem. So the client already got OK status. There was something problematic in the cluster, and there may have been this problem for a much longer time. And these 2 nodes that now went out, they might have been used for the application. For example, you could have been reading from these nodes data that should not be there. So you can say that with this error voting protocol, it's good for handling the error situation. Instead of losing your cluster, it probably will remain as a smaller cluster. You can continue, but you still have to do your homework and figure out that why this problem happened. If there was data inconsistency, when it happened, when it was injected in the cluster, and what problems could that have raised earlier. Okay, Lee.
Why do I, as a DBA, has to do that? That's the task of the cluster. Why can this situation happen at all? I say it's your task to make sure that it will never happen, this situation.
Yes, that's of course the target, or the ultimate goal is to never let anything bad to happen, but you can still shoot your own leg in various ways.
It should never happen, but if it does, it should be.
It's a workaround for some bugs.
Yeah, there can be bugs, or then you can still misuse the cluster You can cause inconsistency at will.
You say user experience is more important than consistency, basically. That's the root cause.
I think that the data consistency is the most important thing.
If you let me something do, which is back with the cluster, because of user experience, then
Well, look, I mean, you should look and see. This thing, for example, runs on top of MariaDB. There have been certain things where some can get corrupted on the MariaDB level. And I know it is almost perfect, but not quite. Right? But, so I think that is a wonderful, like, in my opinion, to have it a repair rather than just cluster crashes and, you know.
Okay, but this is what we have now. So, it's already, this feature is a pull request, and I believe it has been merged already in 10.5 community version.
So the question is, how do you log inconsistencies? Is it just goes into like text or log, or is there something that you just say, hey, you know what, this is how a protocol operates, right? And in the end, we resulted into deleting this particular role, right, from all nodes, right, or something like that. So
yeah, of these problems, you can see in error log that what happened and how the communication went with the consistency.
Okay, so
error logging.
part of the error log, right, if I want to do some automatic reporting of, hey, the inconsistent was spotted and that was resolved.
Yeah, but then on top of that, also with the earlier releases, you get to see the cluster dumps the problematic writes, so that you always get to see the binlog events that this was the troublemaker. But usually it doesn't help you. In many cases, just it's a post-mortem analysis, and maybe the problem was not in this write, it was some write earlier, maybe a year ago there was a bad write.
Yeah.
So it's a really problematic error situation. Alright, next up is XA transaction support in a cluster. This is a work that has been contributed by Daniel and Leandro. Okay, we have a question.
Yes, sorry, one quick. Is there any option on the level 4, like, I got a duplicated key, and instead of aborting the node, we can, like, skip certain types of waivers?
There is now coming with this error logging protocol pull request. It's possible to kind of classify the problems for which problems you will react to and how harmful they are. That is also present in this picture. Okay, XA transaction support. So Daniel and Leandro have contributed, mostly Daniel, for this one. And it was possible to start implementing this after we for MariaDB 10.4 we brought the streaming replication, and the XA transaction support is based on using the streaming replication in the first place. And the streaming replication framework, it works as a building block for many more future features. This is the first one that we are going to release. Now that we have this, Daniel has pushed the pull request about this a couple of times. It's not yet merged in the 10.5 community, and there's one blocking refactoring for MariaDB XA handling in general, and it's in a pull request phase as well. And our cluster level XA must go only after this refactoring in the MariaDB side have been made. There will be conflicts between these two massive pull requests. But from our side, the work is completed. We are just waiting for this merging effort to happen. I hope we have time enough to get this in 10.5. This is the animation again about how XA transaction support works in a cluster. Here is a client who wants to run an XA transaction in a cluster and connecting to a one of the nodes starts the transaction with XA beginning, so you can see that the transaction is launched, it's running in one node only, then it issues various data manipulations pushing to this transaction. Finally, it goes to XA prepare states, and now what happens is that we replicate the XA transaction in the prepare phase already. And you have XA transaction running in the first node, but then the other nodes, they have a streaming replication transaction. So it copies, or we replicate as one fragment the full contents of the XA transaction. So it's a one fragment containing the full transaction, but it does not have a commit flag on. So it tells, it's telling these other nodes that this transaction will have more payload to come, and they are waiting for the final fragment to come through the stream replication to replicate. And then finally, when the client says XA commit or rollback, either one, we will replicate this command, and then the streaming replication transactions and XA transactions can either commit or rollback. So it looks pretty simple after, based on the streaming replication. But implementing the streaming replication was a big task, and also the XA was not that easy. Also because the work that Daniel and Leandro did, they actually had to fix those issues that now are present in the MariaDB XA pull request. That's why they are conflicting pull requests.
So are you looking to do any kind of fixing or are you using overhead of streaming replication compared to non-streaming?
That remains to be seen. We need more feedback about that. So the biggest maybe challenge is the number of replication rounds. So if you slice a transaction to small pieces, small fragments, instead of one commit, you need to send several round trips to the cluster.
Yeah,
so the communication is elevated. But with the XA, you got two rounds. It's like a two-phase commit, basically. You just tell that prepare this transaction, and that's what the nodes did. They started the transaction. It's a high priority transaction. They get the logs. They have the right to get the logs. They will kill everybody who was blocking them, and then they are waiting that will I commit or not. So, but two rounds, so it adds some overhead there, but that's what XA is all about. You need to have those two rounds.
No, I think it's XA, I understand, I mean, more of a speed, because in general, right, if your transaction is small enough, right, you update a couple of rows, right, you would imagine there should not be any difference, right? If the transaction is large, maybe choice between not being able to replicate it at all and stream.
Yeah. With the streaming replication, our kind of target was to make it possible or to protect the cluster of having problems with the transactions. I have seen in practice that if there's a big enough transaction, it looks good in the node that you're connecting. You can have a long-term transaction, you can run it for hours, you're just inserting data in one table that nobody is using. But then when you replicate it, it's a huge one, and every node must apply this. And we have a strict commit order, so everybody must wait until you have apply. And it can take, like, I've seen 27 minutes in one situation, but the cluster is just
I don't understand, but I think in this case that is exactly why you would want to have a default, right? Because asking user to understand that's kind of too hard, and to make it default, you probably don't want it to have a significant performance.
Yeah. Okay, moving on. So with this XA transaction, which was actually one of our targets also, was that we ultimately could implement a sharding cluster by using a spider. This is what spider does. Thanks to Kento, we have it. Kento in a back row. And this is what it does in a very naive vision about it. We have a table. You can partition to it, any number of partitions. Here I have only 2 partitions, and then this spider storage engine can relocate these partitions to separate nodes. And the communication between spider storage engine and the shard server must be XA, and wouldn't work without that. So now that we have a XA supported in Galera level, we actually can build this type of system, a spider cluster, a sharded cluster where we have the spider nodes are in a Galera cluster, which can be relatively small. You can have other tables, not only spider, you can have MariaDB engines and that sort of data. Then those big tables that need slicing, they would be of spider storage engine. And then when you manipulate your data, the big tables will be relocated to the underlying Galera clusters with the 3 nodes or 2 nodes and an arbitrator. These are the choices that you can use there. So with that, actually, it's not only for big tables. It will help a lot in the performance bottleneck that will be seen later when when you are looking for ultimately high transaction throughputs, because the bottleneck with Galera replication type of systems will be in the certification protocol. If the transaction intensity grows higher, we need to maintain a certification index of all the writes that have been present in the cluster in the history, and this index is growing larger, and you have more and more kind of activity for the index. It will be the performance bottleneck. But in this system, we have a totally separate clusters. So these underlying shard clusters, they don't know anything about each other. They just work on a much smaller data set, much smaller number of conflicting transactions. So the certification index is per each of these clusters is much smaller, and therefore optimally you can get a much higher throughput of the total system. So this is on a paper level still, but all these kind of Lego blocks are already in there. We are planning to put a specification how this could be done and what is required for how it could be tested. Okay, Marko has it.
Yeah, I think there is a blocker bug for this feature about the review creation. If you are reading from the spider tables, then you will not get the same review from all the data nodes. That's in there 16610, where the problem has been described by Mattias Nilsson. Mattias Nilsson from Booking and Father Bach, and we discussed, and we got a kind of a workable solution for that. It just needs to be implemented, but I think it must be done before you can pay that this works.
Yeah, I have learned that, but it still works. This was discussed in the Tampere meeting.
Yes, but I think we should discuss this still.
Yeah, but it works if you use serializable isolation.
Yes, if you use locking list, then it should work.
Yeah. It's a performance degradation there, but okay. But for optimal solution, I mean that your fixed for this area should be implemented. But in theory, if you are using serializable isolation in those lower level clusters, you're fine. I claim that. I can even bring you some proof, but not in this talk. All right, let's go on. So non-blocking DDL, this and the next one will be, or are in the enterprise edition pipeline, at least at the moment. Non-blocking DDL was mostly implemented by Teemu. It divides the execution of data definition, data control statements in 3 phases, where 2 are replicating. First phase is that we replicate the original statement as it is as a string, and then we execute this until we have gained the metadata logs for this operation. And then the nodes in phase 2, they just, every node now has the incoming DDL, and then they start to execute it or apply it in a native way with the protection of metadata or whatever that protection is. And then in the last phase, when this execution goes to the bottom level so that we would want to release the MDL logs, it has to wait until all the nodes are ready, and then they replicate the second write set about let's release the logs at this point. For configuration, there's only this change in the VSRED online schema upgrade method, which used to be total order isolation or rolling schema upgrade, but now we have also MBO. It comes from the non-blocking operation. It's not only about the DDL, but the super.
And is it crash safe in terms of, you know, if a node crashes right in the middle and you have SSD happening?
That depends on the capabilities of MariaDB itself. So it's not a replication thing to say. We just replicate this, and if the node can recover or not, I don't know. It depends maybe on what type of change was done in there. But it's not a replication dependent thing.
Okay.
Here is how it goes and how much locking this actually is. When I said non-blocking, it's a fake news. There is locking, but this is what happens in this sequence number. The client is on the left-hand side. It wants to alter a table. It sends this alter command to one of the nodes. The first node realizes that this is alter. Okay, I need to replicate this to the cluster. Because we are having NBO defined as a method, then we just replicate it to the other node, and they both execute this locking phase in total order isolation. So nothing else happens within this first phase. Nobody can commit anything between these timestamps in the sequence diagram. But that should be quite small, so I'm exaggerating quite a lot, so those locking phases are quite small, and the alter processing usually is much longer. So this is to the point when you get the logs, and you have a high priority. So if you cannot get the logs, you will kill the victim, and then you get the log. So it's a kind of a brute force thing. In the second phase, the alter processing is native. So whatever MariaDB does with this alter, it's not what MariaDB does. We don't care. And in the end, actually, these usually don't enter to the end phase at the same time, so nodes progress in a different speed. But when the first one has reached to this point, it will replicate that. Now it's time to end this alter, and it's waiting for others to join. And when everybody is ready, then they will agree that what is the sequence number for this latter replication, and then within this slot of sequence number, they will just release the MDL log, and that will let everybody else to use the table. And when that is ready, then we keep OK status back to client, and client will be happy at that point. Whether it's crash safe or not, it depends on how MariaDB recover if they happen something problematic during the alter process. Okay, finally the last feature, quickly enough. So this is black box, something you maybe didn't wait to see, but for the effort from our side to harden the cluster to make it less vulnerable to any problems. Basically what it's a ring buffer of debug messages pushed by the cluster, and it's relocated in main memory and shared memory segment. We use POSIX shared SHM API, and the idea here is that it would help in troubleshooting a crashed node, and on the other hand, it will help in testing the cluster. So with this, you can actually run all your tests with maximum debug levels and still get to see the concurrency that you were looking for, and might be able to surface the problems that would not surface if you were logging all your log messages from disk. Because when you log to memory, it's much faster. There are two configurations. Maria is coming. Black box name, so it's the name of the shared memory segment, and then the black box size in bytes. The black box, it's a ring buffer, it's in a shared memory segment. If the MariaDB server shuts down gracefully this segment, so it's a separate segment, during the shutdown we clean it up, we remove it, it's not needed anymore, nothing bad happened. But on the other hand, if the MySQL crashes for some reason, whatever it is, if the shutdown is not graceful, then the shared memory segment will remain in the main memory. It's possible to attach to it, to take a look at what we have here, and then from this information make some conclusions. Then one more thing about this, that when you start up MariaDB server after a crash, you attach to this shared memory segment, then you see that, okay, it should be empty, but there is some contents. Then the MariaDB server knows that the previous incarnation of myself has crashed, and there is maybe some valuable information in the ring buffer. Then it first dumps this buffer to a dump file, and then clears the black box and starts operating. So the server is able to start, but you can still find the contents of the black box on your disk. The idea was that, okay, I have this slide two times. The plan was that it should not affect transaction throughput. In our requirement specification, we talked about that something like 5% drop could be on that level could be still acceptable. And this has been reached on manual testing during this feature, but of course it depends quite a lot at how much you push data to this black box. At the moment, this is the first version. We are just making all cluster-related log messages, which are currently triggered by a macro in the code base, debug macro, and all these debug macro pushes, then we direct those to the black box. But basically you could push any information in there, not only from MariaDB, you could put whatever from any other processes, from operating system level as well. Then there's one more thing, is a tool. So when you have the black box running, there's a command line tool that you can use to attach to it to see that what is the status of the black box at the moment, and you can, for example, dump it at will if you want to see that what we have here. If you want to analyze, for example, the slow performance of a certain query, you could take a look that when this query hits the server, then you dump the black box. At that time, you can see that if there is something that in debug level have been messages about this operation, then you could maybe get a clue that what happened. Here is the picture how it looks. So MySQL MariaDB just pushes, it first attaches to this shared memory segment. The size of the black box is quite important. I didn't mention about that earlier, but usually I think that just 1 second time window, what happened just before this crash happened, would be enough. But you could make it bigger or smaller. It doesn't affect the performance at all because it's a ring buffer. It just overwrites everything. And one thing to figure out is that how much and wherever in the code base you want to push messages in there and how long time window you gain with that, so that you would be able to do the post-mortem analysis based on that time window. So something to monitor and play with. It's our first implementation that is coming now, and we're just learning about what are the good kind of tunings for this feature. Alright, that was last one. I was a bit over time. I'm here until afternoon tea. Any more questions about this one? Everybody's happy and nodding, so I thank you for listening to this presentation.
Yes.
Hello, we are like right now top time, but let's make it different, okay? Just 1 minute.
Who could borrow the laptop for 20 minutes for me, please?
May I copy the email to you? One second, is this document application time previous MariaDB Brussels? Never seen that before. Now PDF crashed.
So that never goes smooth enough. Let's join please back.
So next session is ready to begin. Please have a seat.
I've started a timer so everybody will be in time for lunch. Hello, my name is Nikita. I was working on application time periods for implementation for my MariaDB server for the last year and a little bit, like half. First started doing it for at Tempesta Technologies team, and then moved to directly MariaDB Corporation. So it's like temporal tables stuff. Everybody knows it like that, and somebody messes up and confuses with the system version tables. But the things are actually different. I want to explain first that part and then move over up to algorithms and data structures and so on, and whatever. Let's start from a complicated example, because what the period is, it is just quite simple primitive. So to make it not so simple, let's have a complex example. Here is a table of transactions. The transactions have ID, the node they are executed at, like an execution queue, and a time at which point the transaction has been started and transaction finish time. So it's obvious that transaction start and transaction end time could form a time period. It's called that. And with a constraint that the end time should be always be more than start time, it's called a period of a table in terms of a scale level standard. So the constraint is always added implicitly, and it should be also followed as well. That's it, and let's now have a little bit simpler example with hotel room bookings. I know there should be some guys from booking, so it could be familiar a little bit. But I think your tables are like more complicated than this one. So I have a table with room bookings and 3 columns, the room and dates for booking start and booking end. Booking start and booking end also form a period. I have the mistake there. Day start and date end made timestamp. Actually, it's just date. Date is enough. And the period could be also made from dates. The important thing here is that you can have several booking rows for a same room, but no 2 rows for a same room could have a common point in time or in date. So, meaning by that the periods for each room should not overlap. That's what it means, and we can add such constraint. This is the new constraint coming with MariaDB 10.5. I hope so, at least. Yeah, and it could be unique, either or a primary key. Any way is good. The data model of these booking tables, it's pretty same like with the previous example transaction tables. You can see that there is a node column. Yes, I called it an execution queue. So an execution queue would only work in sequentially, so transactions could execute in parallel, but on different execution queues. Execution queues execute sequentially, yes. So this means that without overlaps constraint could also apply to this kind of table, and it's pretty same. And except that we have a transaction ID as well, which is primary key here. So now back to the bookings example. This slide is the same as the previous one. And just to make sure, to make clear, here is one more row, and you cannot add it, you cannot insert it because it overlaps with the previous one. Like, you cannot add a booking because you'll have an overlap. Yes? I think it's clear. Cool. Now, how it works? On the first glance, well, we haven't have such kind of constraint before. And what to do? I'll tell you, the table of such kind has already a without overlaps constraint, which means that all the periods for each key go like second key. So that means that we can, if we are inserting the row like that one for a booking in the hotel for like MariaDB Day from 1st February to February 3rd, you can see an overlap here with the period marked as from date start to date end. Yes, and the important thing is that date end is more than February 1st. It is more than the start of the period we are inserting. But you also have a period here to the right, and the end of that period is also more than the start of the period I'm inserting, the 1st of February. But if we'll get a lower bound of the set, like all the periods which satisfy the condition where that date end is more than 1st of February, then we will get a potentially overlapping row. And just check if it overlaps or not. So that means that it is just enough to have an ordinary B3 key with room and date end. Actually, the implementation also adds date start as well for the optimization purposes, so I can use keywords. That's it. Now let's go forth to foreign keys. Foreign keys are also going to be added to 10.5 as well. In this example, I have another table with the prices for each room for a certain period of time. The model is done so that you can have some points in time where some rooms are not available, and that means that there will be no record in the prices table. But this model could make it very simple to calculate the income for a certain period of time, minding the bookings table and the table of prices for those days. We can add an referential integrity with the periods. That's how it works. The colors are a little bit cumbersome, but I'll explain the model. So on the top half, you have a prices table for some room, and here are one set of prices from January 1st to the middle of January, and then up to February 4th, there is another set of prices. And then like some maintenance day maybe, so no price for the day. I think that's kind of realistic because a lot of people on the New Year month on January go to traveling and so on, so they book a lot, and it's reasonable that prices in the first part of January could change well to bigger side. Yes, and then they will slightly change down, and it's reasonable to have some maintenance day, but let's just make it after MariaDB Day so we could book the room for us for this time. And you can see that you cannot book from, say, 3rd February to February like 8th. It's marked with red, that period, on the bottom half. It's impossible because it violates the referential integrity constraints with periods. Although, you can add booking from somewhere middle of February to the end or to the middle of March, somewhere there. Though it covers more than one row and different prices. That is possible and that works. That's why the referential integrity with periods is added to a standard. Now a little bit on the architecture before I will start talking about algorithms of referential integrity. So everything I was succeeded to make everything implemented on a higher level, like SQL level and the hand load level. There is just a little bit of code in MariaDB right now, but I hope it will be soon removed. The referential integrity itself is done in handler, which potentially allows us to have foreign keys between different ranges and so on. By the way, I want to mention some work of my colleague, Alexey Medenkov, who did a great job of throwing out the internal parser of foreign keys from MariaDB. It was there for the whole time. And now he is working on making the DDL of foreign keys also on the upper layer, making it stored in FRM files. After that, I think it will be really possible to have a cross-engine foreign keys, at least for the periodical constraints. Now, what if we want to delete the row in case we have a referential integrity? There is one point I should point out, that SQL 11 standard allows have cascading integrities in such case. Only restrict is possible. So we should, when we delete some row, we should only check if the integrity is violated or not. And how to do that? Consider we are deleting the row with a period from del start to del end, like on the picture. It's a parent table. And there could be, in the child table, there could be some row with from ref start to ref end. So if we delete the period, the constraint will be violated. What to do? And how to check that? We already had an example with without overlaps, a constraint check, when we are just finding the lower bound by searching the value of del end. That will not work in general in this case, because consider this example. The child table could have no without overlaps constraint, and then all those rectangles on the bottom half of slide are the periods from the child table. So, actually, if we'll search for the lower bound, the first record will be found is marked with the old red on the down there. And it does not overlap with that bold period I'm trying to delete on the half part, or on the high part of this slide. And actually, there is only one period that overlaps with the deleting one, which would violate the constraint. And if you will try to find the lower bound and then go like next, the really overlapping one, will be found the last. So, generally, we will have a linear complexity of this algorithm. That's a pity. And what to do, we maybe could use an R tree to find the overlaps in this case. But let's see, it's not implemented right now, just a thought. Now vice versa. If we are inserting some row, we should also linear. And the last part I want to mention about algorithms is update. You can see that if we are just updating a period like that, we can treat it like a delete and insert. So just make it delete check and insert check independently. But that is possible only if the period we are updating from doesn't overlap with the period we are updating to. In other cases, like if we are just shrinking a period, we could have a false positive constraint violation. So we actually should just check for deleting that small portion we are shrinking. That small portion we are shrinking, actually. That's all. And for insert we could do the same, but it's not required. It's just an optimization purpose, nothing more. So I think I have covered most of things I wanted to tell you about, and now where we should go next, I think that the most important thing is actually the optimizations. There are plenty of work could be done on that. For example, either we should call optimizer or not, or maybe implement some data structure, or other ways to make that algorithms non-linear but constant. And to support views, currently you cannot make a table or make a view to the table with period, like that. And there is a part of SQL standard as well with period operations. It's nice, but it's also not implemented, just not enough effort to make it into 2.5. And I've also already mentioned about cross-engine period references. I think that this is possible in future soon. Thank you. So now I'm glad to invite Kai to invite you on dinner or on lunch.
Well, not really dinner, but lunch, yes. So the logistics for the lunch is.
It's supposed to be brought here, but I don't say inside.
So we have to fast for a while.
Yeah, on Belgian time.
Virtual Belgian
90 minutes, exactly. Thank you. No, yes, this one is furnished, but they really try for you can just
Okay. So I would like to give a status of.
One minute, everybody, can we have Marco now?
Okay, so I would like to give a status update of MariaDB development at MariaDB, especially for the 10.5 version that we are working on, and some ideas that what we are going to do in the future. So what we have done so far, one important thing was fixing or cleaning up the change buffer, which is used for speeding up some operations on secondary indexes when the page is not located in the buffer pool. It will avoid a read from the data file and instead buffer the operation in the system table space. And for that, this first task, deferring the change buffer merge, it was a minor slight performance improvement, but most of all, it avoids some random crashes. So if you got a corruption on the change buffer, earlier you could get a crash just randomly unrelated to the current queries. because the InnoDB background task would do this change buffer merge, and it would at random point come to read this page and try to apply the corrupted changes to it. So now you can only get the change buffer merge when you are actually accessing the secondary index page, and then you have a more direct connection, you know what is causing the problem. And later on this will enable further work on the change buffer to replace the current change buffer format with a more logical one. But that's not going to happen in Ten5. Also, what Vlad Weintraub did in Ten5, he got rid of many InnoDB threads. So he implemented a thread pool for InnoDB tasks. For example, we don't have dedicated purge threads anymore. We have purge tasks that are run in that thread pool. And similar for some other things such as full text index optimizer task. We are working on the replication side. That is related to the comment I made yesterday when Jean-Francois was giving his talk about the sync binlock E+1. So we should be able to reduce the number of fsyncs. Basically just fsync the binlock and avoid the InnoDB redo-lock sync. That should give some performance improvement if you want to use the binlock and use it in a safe way. Also, we are planning to remove the option to omit redo-lock for some DDL operations. Currently, starting with MySQL 5.7, alter table of rebuilding the two optimization on crash recovery. We have this task which is done in Ten5 that you can actually remove the double write buffering of some pages. If the page is being initialized completely by the redo-lock records, then you don't actually need to write the page with the double write buffer. Except if we have this lock optimized DDL enabled, then we can't enable this optimization because the user could change this setting of what the server is running.
Excuse me.
Yes?
If you work in case of crash and recovery, you are using the binlog persistent instead of the redo. Did I got it right? You are only to use synchronous fsync for binary log, not the boost?
I have a later slide on that, but basically, if you ensure that the binlog is always ahead of what has been written of the InnoDB redo-lock, then we can do recovery from the latest binlog position that InnoDB knows, and then replay the binlog from that point on. That's the basic idea. But of course, it requires that you run with sync binlog equals 1, I think. We have done some scalability work. So we have this first task is to do some kind of adaptive purging that's only at the raw idea stage. I think that will miss the Ten5. And I am currently working on a new InnoDB redo-lock format. Then we are working on page flushing improvements, which I will cover in a later slide. We would also like to remove multiple InnoDB buffer calls, but that's still in progress. We have run some benchmarks, and there is some regression in some cases, so we need to identify the exact bottleneck and what to do to address it. In Ten5.1 we also will remove a dummy table space for the InnoDB redo log. InnoDB has its own like wrapper on top of the operating system file operations, and this fill IO call was also used for writing redo log for apparently no good reason. So we removed that, and we are writing the redo log in a more direct way. Then we have this last thing is about the freeing pages or scrubbing pages that are no longer allocated for anything. I hope we can also do that. It would improve utilization of the SSDs, because it would send the trim command to free the space to the SSD management. Also, it would replace the current InnoDB scrubbing feature that exists in MariaDB. That one is, I feel it's kind of a hack. It's not using the redo log properly and so on. Oops. Okay, so first a word on how the InnoDB writes work, or what kind of constraints we have on the writes. So any change to a persistent page is encapsulated in a mini transaction. It's not the same as a user transaction. A user transaction can consist of multiple mini transactions. A mini transaction is like insert this record to this B3, and if you have to split the B3, then do it all in one atomic step. Like allocate this page for the new leaf page, and then update the upper level page to have a pointer to the leaf page and insert the record. Everything has to be done in a single mini transaction. So the user transaction ACID is building upon this, but typically the user transaction will consist of multiple mini transactions. First, write undo log and update the cluster index, and then if there are secondary indexes, update those, and then for the next row, write undo log record, update the cluster index, update secondary indexes, and so on. And finally, a mini transaction that updates the undo log header to say that the user transaction is committed. So the mini transactions are totally ordered by a log sequence number, which is kind of a logical timestamp. And the mini transaction is durable if the write of the mini transaction has reached the redo log. If the crash recovery code can find that the end of that mini transaction in the log, then the mini transaction is durable. A user transaction commit is durable if the mini transaction of marking it committed is durable. And the mini transactions are totally ordered, meaning that if you commit some user transaction, you must write mini transaction log for any other ongoing operations that were submitted before that time. So that is how you can get some incomplete user transactions to the redo log. And we may have to do a rollback of some operations, because some other transaction might have done changes, and then you got a user transaction comment from a different session. It will have to write the redo log also for the previous, also for other sessions which have not committed yet. And we have to follow the write ahead logging protocol. That means that before we can write anything to the data files, we must first write it to the redo log files in a durable fashion. And only after that we can write to the pages. And to shorten the time needed for crash recovery, we do log checkpoints. Basically, it's discarding the start of the redo log. Logically discarding the start of the redo log and saying that now everything up to this time is persisted in the data files. So with the log checkpoint, we must write the user data pages up to that time, and then we can update the checkpoint information in the log header. The page flushing was simplify the bit in this task, thread pool task that Weintraub implemented. So basically, the log flushing and page modification, it looks like this. You have a mini transaction which encapsulates both latching operations, like which pages were locked or which pages are going to be read or written by that mini transaction. And it also contains the log for any changes that have been done in the mini transaction. Typically, the latches that are in the mini transaction, they are the index tree latch, which protects the upper layers of the B tree. And you might have the table space latch, which is used for page allocation. When you allocate a page or free a page, then you have to acquire the table space latch because it's protecting some data structures, some pages in the table space file. And then you have the page latches that you are going to read or write. And in this example, the dark buffer pool pages are pages that have been modified in the mini transaction. Those we have to eventually write to the data files. So when the mini transaction commits, it can immediately release those pages that have not been modified, and it can also immediately release the index tree latch and the table space latch. But for this dirty page, it has to first write the local log buffer to the global buffer for writing into the real log. And finally, at some point, we will flush the log from the global buffer to the real log file, and after that we can flush the data files. And we must also write this LSN to the data pages so that recovery knows if it has to apply some real log or not. So currently we have a mutex contention on the log system mutex because basically any thread that can modify pages will directly write to the global log system buffer. And also any thread can initiate a log checkpoint. This means that you can have multiple log checkpoints occurring at the same time. It's kind of counterproductive or not useful. So we have an idea that maybe there should be a dedicated log writer task, and the mini transaction commit would hand over just detach the log from the mini transaction and let the dedicated task do the writing. But this is a rather raw idea stage yet. We don't have any prototype implementation of it, and it might miss the 10.5 time frame. Also for the page flushing, currently we have a hook there that when the page cleaner is flushing a page, it will check if the real log has been flushed up to that page LSN. If not, it will actually wait for the real log flush to occur. I think that this can reduce performance. So I have been thinking of skipping those pages which haven't reached the real log yet. Okay, this thing, removing a redundant field from the page descriptor, that is already done. So we just use this field in the page frame directly. Now about the redo log format redesign that we have been working on. The first task is almost done, introducing a new encoding for the redo log records. So previously, MariaDB had a mixture of physical and logical logging. For example, for inserting a record, there is a special type, or for updating a record, there is a special type. But when I introduced the more compact table format in MySQL 503, we had to add some index metadata to these logical records, and it's writing quite a bit of additional data for simple operations such as inserting a record. So for those operations, it's actually more efficient to just have physical logging saying that please write to this page, these bytes on this page at this offset. And that has been done, but we still are missing some optimizations. For example, if you are inserting multiple records to the same page, then the records will have the same prefix, but currently the state of the code is that each record that is inserted to the page, even in the same mini transaction, they will write that common prefix for each record that is inserted. So some optimization needs to be done there to be at par with the old format. This new format, I think it will open new possibilities, such as physical replication similar to what Amazon Aurora does. And we could maybe use dual licensing for the readlog record handling code. It could be linked with some third-party distributed file system, because we own the copyright. It's not bound by the Oracle GPL. Another task is related to structuring the readlog files themselves. So the idea is that we would have a separate file for log checkpoint information and file operations, and then have the page level log file separately. And this looks promising in our benchmarks. Especially with the NVDIM, we can use memory mapped I/O right directly to the persistent memory. It will not use any system calls to write the redo log. Yes?
With this implementation, it means that you're going to flush the whole page through the Hadoop instead of the physiological. So the space used is going to grow.
It's not the logging whole page images of the redo log. There are different redo log types, such as write a string of bytes or copy a string of bytes from other location in the page. For example, for inserting a record with a common prefix, the optimization that is missing is that instead of writing a record for writing the whole record, we would write a record, copy these bytes from the previous record, and then write the tail. So it's not that bad, but it's still, in some cases, especially when reorganizing a page. For that one, the old format will use a special record saying reorganize page, and then it includes the metadata information for describing the record format. For that one, we are currently emitting a lot more redo log, but I'm going to fix that. Write the multiple files in parallel, but that seems to be a doomed idea, because if you want to have a durable transaction, then worst case you have to do a durable write of all the partition log files. So we scrap that idea. I think that this new physical redo log format will be easy to pass and fast to pass, because we are not allocating any memory when passing the log, like we currently are with the old format. And this new format would also allow variable size log blocks. Instead of having a fixed block size, we could have variable size, so that we inject check some record at the end of a durable snippet. And for even more flexibility, we put, or we should make the log sequence number count actual mini transaction commits instead of counting bytes. This would allow the incremental Maria backup to inject some records to the redo log without changing the LSN. And we could even get rid of the requirement to run a prepare step with Maria backup. We might allow the server to directly apply the log that previously was done with Maria backup. But I'm not sure if this will happen in 10.5 yet or in the GA release. Okay, so basically this IB log file 0 would degrade to a dummy file, or maybe it could contain the checkpoint information and the file level log. But we need to have that file so that we can prevent downgrade to earlier versions and also to have a smooth upgrade. It's a kind of a placeholder file that identifies the log format. And then we would have a separate page level log files, and we might introduce an append-only format later. I think that the circular file is better, at least for now, because it can be written much faster. If you have append-only file, then you have to allocate pages and write pages, and that adds some file system overhead. This checkpoint information file would contain multiple checkpoints. In the current file format, there is only space for 2 log checkpoints. So the log header will contain the latest checkpoint and the previous one, so that when you are doing a checkpoint, it will not overwrite the existing checkpoint. But I think it is more flexible to have multiple checkpoints in the log file. It could even allow some more troubleshooting, or in debug builds we might want to start the recovery from the first checkpoint and to ensure that the log apply code is bug-free instead of starting from the last checkpoint. And this checkpoint information file would also contain all the file operations, such as creating, deleting, renaming, or modifying files. This would speed up the crash recovery, because currently we have to scan the redo log for this file level operations before we can start to apply page log. But if we have them in a separate file, we can first read that file and then start reading the page file. Well, a normal page flushing mechanism handle that somehow. I'm not sure if we need a two separate types of flushing, which we currently have. And maybe we should try to sort the flush list in the same way at all times. During recovery, we have a special sorting which is speeding up the recovery. I think it was introduced in MySQL 5.5 or 5.1 already. Also, one thing we would like to do, but it seems to be hitting different blockers every time, to execute the crash recovery in the background. Currently, I think we need to do something in the page flushing first, and then we can look if it actually works. This crash recovery in the background, one blocker of it was this background merge of change buffer pages. And once we remove that, then we got this next one that, okay, this one is still preventing it. I would also like to remove multiple buffer pool instances. I think that they were originally introduced to address a bottleneck with the buffer pool mutex. And since this happened in MySQL 5.5, the buffer pool mutex has been already split quite a bit. In MySQL 8.0 it was split further. We don't have that those optimizations in MariaDB yet, so we should probably do that as well. So we have done some recent benchmarks, and in some cases with 4 buffer pool instances, it's currently a bit faster in a right benchmark than single buffer pool. We need to find the reason for that, find the bottleneck and fix it before we can remove the multiple buffer pool instances.
So one question. So when
yes.
you say doing the recovery in the background, do you mean that you will start user transaction earlier, but they might have to wait if they want to access a page that has not yet been recovered.
Yes, basically the crash recovery in the background is already happening internally when the InnoDB startup code is reading the review log and reading the undo log pages to reconstruct the transactions. It's already kind of doing review log recovery in the background, but it will not return from that function. It will not return from the InnoDB init function. So basically, the idea is that we will let these recovery data structures be in the memory, and once you read a page for which, once you request a page for which there is a review log to apply, then we apply the review log before giving the page to the user thread. So it would be completely transparent. But currently, there is some call that because there is a different page flushing wait for the crash recovery to complete before InnoDB startup completes. If we clean up that, then I think it should work. There have been several small things that we have had to remove to make this background recovery happen. But the last one that I can think of is this page cleaner. And then we have this bottleneck caused by durable writes or F-sync. It's kind of an overkill in some cases when we only need a write barrier. Basically, any important state change, usually it's a user transaction commit or XA prepare or XA rollback or XA commit. Those are important state changes in MariaDB. Those need to be persisted, and they are persisted by making a durable write of the log that is at least including the LSN of that important change. One future idea to speed this up is that instead of waiting for this log write inside InnoDB, we could set up an event for log write completion that would then send the OK packet to the client. This would help if you have a client connection that is sending multiple transactions, like begin, do this, commit, begin, do something else, commit, and so on. So it would, InnoDB would be able to process the next transaction already, and when the log write for the previous commit happens, then only then we would send the OK packet to the client. That's not going to happen in 10.5, but I think we should look into that. For bin log driven transactions, we don't actually need a review log write for InnoDB. It should be enough to do a durable write of the bin log. We just need to ensure that the InnoDB review log is never ahead of the bin log. And recovery can be done by applying the bin log since the latest state that the latest position that InnoDB remembers. And maybe in some future we can look at this lib uring to implement write barriers without F-sync. I think that we only need F-sync for log checkpoints. We must do a durable write of the pages, of the data pages before we can write the checkpoint information. And of course, for log writes, we need something like OD-sync or FData-sync to make those user changes persistent. And oh yes, when we do this bin log optimization, if we do bin log rotation, then we must make sure that if we discard the start of the bin log by doing this log rotation, we must also do an F-sync or durable write of the InnoDB log at that point. Then last, I have some longer-term ideas what we could improve. So this lib uring was already mentioned. I would like to eliminate the InnoDB system table space at some point, or make it optional so that when we upgrade, then if there are user tables in the system table space, you can still access them, but you would not be able to create tables in the system table space. So one thing, maybe it's going to happen in 10.6 is a logical change buffer. Currently the change buffer contains space ID and page number and then some index metadata and then the operation code and the data that is going to be inserted or deleted or delete marked. I think that we should, instead of doing that, we should have a table ID or index ID and then use that instead of storing the redundant metadata. It's described in that endem. Also the InnoDB double write buffer, if we still need it, maybe we can get some Linux improvements that allow us to do atomic writes. Maybe we don't need the double write buffer at all, but if we need it, then we should move it to separate files or use pmem or npdim for double write buffering. Also, we would like to remove this dictionary header page, this field which is currently used for the hidden primary key of tables that don't have a primary key. We could have a per table DB row ID for those tables. There's no need for that to be a global sequence. And finally, the persistent statistics for InnoDB. Either I would like to remove them and use the MariaDB engine independent statistics, or if we have to keep them, then I think the proper place to store them would be within the data file itself and not in a separate table.
I find
Yes.
the table is very useful to be able to take the statistics or make the statistics static so that they don't change when I'm doing regression testing.
Yes, that's one thing that should be addressed somehow. We would need some interface to inject the statistics or whatever to allow the same. Definitely, I mean, we have some optimizer bugs that only very randomly a bad query plan is chosen, and if you can't fake the statistics, it's very hard to reproduce those bugs. So it is useful. Then for undo logging, currently the InnoDB undo log format only allows one table or partition to be created in a single transaction. And that is complicating the code for creating or altering partition tables or doing DDL operations on full text indexes which internally use multiple InnoDB tables. That one, which would mean that nothing would be destroyed from the data file before the DDL transaction has been committed. It would be basically done on the purge. I would also like to simplify the import table space, maybe even so that you can just copy the FRM and IBD file and do a select or whatever, and it will magically just work. That would be the ultimate goal. Just like it works from my ISA and ARIA. Then finally, for InnoDB logging, there are several MDEVs. Table logs I would like to replace with MBL, metadata log if possible. And for record logging, there are several things such as we should use implicit logging for update and delete operations. Currently, it's artificially split so that the mini transaction is committed and before that we create an explicit log which will then be used by update or delete. It would be more efficient to keep the page latch and use fewer mini transactions basically and do implicit blocking for updates and deletes as well. For instance, the implicit blocking means that oh, did it move the screen even? Yes. For inserts, we do implicit locking, meaning that we write a record with the transaction ID to the page, and then if others read the record on the page later, they will find out, okay, this transaction ID belongs to an active transaction, so I must request for a lock for this record if I want to lock it. And that same thing would be done for deletes and updates. We would also like to move foreign key handling out of MariaDB. It was already mentioned by Nikita in the previous talk. And this non-blocking commit I already mentioned. And okay, using favor mini transaction, that was I mentioned just before. An important thing is also this bulk insert into empty table or partition. If you are loading, for example, a MySQL dump, currently it's doing completely unnecessary undo locking for each record that is being inserted. If we detect that the table is empty, we could just write an undo lock record saying that if this transaction is not committed, then on rollback please truncate the table or partition and then skip all the undo logging and build the indexes like in create index. Basically sort the records for each index and insert as a bulk insert. That would also help with algorithm copy operations. Those are the tables that we cannot support natively. Reducing number of mallocs done by MariaDB, that's also important for performance. And for other tables, some ideas that would be nice to have. Okay, that was it. Any questions or comments? Yes?
The development of Oracle MariaDB and MariaDB nowadays, can we look at that as completely separated, or what is the state?
Yeah, but the status is that we are not merging changes from MySQL 8. No, at least not much. Maybe some we might do, but the code base has practically diverged from 5.7.
Okay.
Even for 5.7, we don't support create table space, which was introduced in 5.7. And maybe some, I can't remember anything else that we don't support for MariaDB from 5.7. Yes, Valerie?
Oh, do you think it makes sense to invent a new name for the storage engine because it's no longer in MariaDB and so the farther we go, we need a new name? Really.
Yes, I agree. We need a new name. I have been telling that a couple of years, but Monty is not in the room, so we don't have a disagreement on that. Yes.
And so your plans are very focused on wide performance. Do you have any ideas about how you can improve read performance? I would like to see heap tables, for example, instead of cluster index, cluster tables. That would speed up a lot of queries.
Yeah, well, we have the areas and MyISAM storage engine, which I think are better for optimizer internal usage than MariaDB.
Yeah, you can't just move the data when you need to run a query.
Yeah, heap organized tables, yes, I guess it could be, but we already have the area, which is a cache-safe storage engine that does heap organized tables, so I don't know how much work do we want to do to duplicate that, but I agree, for some cases it would be better than this index organized clustered index. Okay, if there are no other questions, then thank you, and hopefully the lunch will arrive at some point.
The lunch will not arrive, but we will arrive at the lunch. So lunch is on first floor, and it has been there already for quite a while. So let's go to the first floor. profilers and how to create face and get to know where time is spent inside programs. It's really exciting. I'm looking forward to see what Valeri has to say.
Can you hear me? I'm not quite sure.
And if it should be there, I comment.
I believe I'm like a not a developer. Shame on me, I am from services. Yes, I'm a support engineer for MySQL of different kinds and now of all kinds, thanks to MariaDB. Since I quit Oracle, I went public and I write about my work and work-related matters everywhere, in a separate blog on Facebook. Everybody is annoyed, probably at some stage with my friends, with posts about bugs, Twitter and everywhere. I also like to participate in FOSDEM. This year I was one of those guys whose talk was not selected for the main track, but MariaDB kindly asked me to try to present one of them. Many of my FOSDEM talks were of a kind something for MySQL DBAs. People were joking like one day we'll give a talk, dev now for MySQL DBAs. It would probably make some sense. I believe today's talk might make more sense. What I would like to highlight about all kinds of slides I ever produced, they have a lot of words and links to everything. So they were already published everywhere, Facebook and elsewhere. So click on all those links, you might get way more useful information than from me talking on this. So this talk is a kind of continuation of what Peter Zaitsev tried to present actually. It's about observability. It's about getting information on what happens inside of your MariaDB server. This is a quick review of all the ways I know to get the insights. So some of these first items were already listed by Peter Zaitsev as a sources of profiling information. By profiling I mean periodically collecting of something related to the way your program, in our case MariaDB server, works. I have something to add. There is also a user start that was not mentioned. There was the very first community contribution from Jeremy Cole to MySQL that still works in MariaDB profiles, specifically added to find out where time is spent during the execution of specific queries, so it was split into stages and carefully measured up to, I don't know, milliseconds at least, as far as I remember. There is also performance schema and everything else. From all that, today I would like to concentrate at the lowest level. You can get a lot of insights by just watching the traffic to MariaDB server and from it, capturing packages, parsing them and understanding the timing for these packages. So that's what the entire business of Vivid Cortex is built on, for example. They're monitoring MySQL, MariaDB, whatever server by watching the traffic in between. So of all these tools, they provide a different detailization of information. Each of them has its own purpose with a different price. So what I care about in support as somebody who has to deal with often very high load at customer side. And the observer, the tools used to capture the information I need do not influence the process I'm trying to capture. So that's why at some stage I came to the need to use operating system level tools. Today we'll speak specifically about Linux. And in case of Linux, I went over several stages. Like 3 years ago, I presented using profilers for MySQL DB, so I already was at that stage that you need to apply post-level profiling tools, different from them. And later I moved to even more advanced, more lightweight profiling tools already available in recent Linux kernels. That's what I suggest you to use. So I will try to explain you exactly what it's about. I will better say what this session is specifically not about. It's not about using the performance schema of all that stuff. Even though it's a bit contradictory to the initial idea of adding the performance schema as a lightweight and very specific profiling metrics and specific performance counters to each and every other line of the code. So for that, the other tools will be also mentioned. Some of them just have too much impact, some of them require debug binaries, or specifically build binaries like gprof that really developers would prefer to use, but we do not have that binaries in production. That would be too slow. Specifically, why not about performance schema? I have like several items to explain. The simplest is, it was already questioned, why is it so that in case of MariaDB, performance schema by default is not enabled. Moreover, in case of MariaDB, in all released version, performance schema is a bit outdated. 5.6, we will get a part of 5.7 performance schema instrumentation in version 10.5. That part, I hope, will cover the memory allocation. It may not cover replication part, because replication is very different. So something easy to port will be added. But we are lagging. The worst thing is that it's not enabled. Other bad things come from my experience. So unfortunately, even if it's enabled, it may be too complex to get the information you need. And unfortunately, up to now, the performance schema instrumentation is not on every other line of the code. If you listen to Georgi Kadino, he made several presentations where he explains how easy it is to add performance schema instrumentation, and it should be every second line in your code. It's not yet there. Specifically, it's not yet, for example, in Galera library. You cannot force third-party providers to put it everywhere. And yes, it has a cost, but even beside the cost, you cannot expect, you cannot rely, I mean a production DBA or me as a support engineer, on always using the top-notch, the latest development and forcing developers to put instrumentation in place for you. That would be great, probably, but it doesn't happen. One of the reasons as well is that it's a historical thing. So ask Monty, does he consider performance schema useful? No. I asked several other developers. They want to see raw stack traces, they want repeatable test cases, but they never want a performance schema.
I can just say that I don't regard it as useful for my work, but I know customers have. The reason I was suggested off by default was that we had some users who got the 25% impact of it.
Yes. Facebook was one of the first adopters who tried to use it at the early stages, and they found out that for production load it's too much a cost for the value they may get. So that this is the same value they may get elsewhere, and right now Facebook uses about at all their servers, covering everything from the kernel to all the applications. So what things I will speak about, they are more lightweight than performance schema, and they are uniform. They equally apply the same tool, the same approach, from the device drivers to hardware monitoring to Linux kernel to TCP stack to memory allocation. All the greatest application of all times, they are running on that stack. So it's all uniform.
But we do have plans to at some time allow people to enable it after the start.
Yeah, that would be great if it's dynamic. There is again some cost, some work to do. My personal item, the last item that what I care about, you know, a typical profiling query that checks the slowest running query in stages they spend time on and waits on each stages would take an entire page, an entire slide. So there is a kind of solution offered by MySQL to that in the form of sys schema, and we have Oli from Dual who is sometimes spending some efforts on porting sys schema to MariaDB that is not yet there. But personally, I would not be able to type this query easily. I need to copy paste it from somewhere. And to run anything with performance schema, you need two things. You need to be able to connect to begin with. And this is a query that, well, it's not that complex, but it would take some time and resources to run. This is a point of performance schema. They try to not spend resources on data collection, but when you query the data, you need to spend resources. You need to aggregate. And if you have huge counters, gigabytes of hundreds of gigabytes of memory performance counters, running this kind of query will take you time. And it may be already at the stage when the performance is key. So, what do I suggest instead? Instead, I suggest to use tools that are presented like to the left and covers full application stack. This slide is borrowed from, well, you guess, Brandon Craig. Nothing special here. Of these tools, some are used already one of the talks I've suggested for this, for them was specifically about perf profile. But there are a number of tools. They are kind of evolving with each Linux version. And why there are different tools, what they provide, what they have in common, and what the point of inventing new tools. This is what I would like to speak about. So of all that tools covering full stack, today I will mention specifically in more or less details that matters. The initial ftrace implementation, that's the basic, that appeared in Linux 2.6, 2.27, so it's in CentOS 6 and in Red Hat 6. Perf is a bit out of topic, but it's used as an example of the tool from the same age. Then at Linux kernels late 3.19 or whatever, and early 4-point-something version, so-called extended BPF tools appeared. And starting from 4.9, as far as I remember, we also have a convenient, useful interface to all that stuff called BPF trace. So that's specifically what I suggest to use. Or try to use. It's not so uncommon to use operating system level tracing and profiling tools for MySQL DBAs. Probably every one of you tried to use strace at some stage, even though it's not a lightweight monitoring, it's a hard stuff. But even recently we have a Japanese customer explaining to us why our thread pool is not working properly for their use case, and they did it by running strace and understanding what system calls happen in production under high load, because in artificial, simple testing environment it had not happened. So the entire idea of using operating system tools, even hard impact one, is not new. People attack GDB. There is PTPMP that is even more hard. So the idea is not new, but what we should care about, we still should care about the impact. So if there are new tools which are more lightweight, we should not ignore them. Historically, the first implementation of tracing I'm interested in, fully dynamic, covering everything, all the application stack, it appeared in Solaris, and it was called dtrace. It was quickly ported to macOS. Like 10 years ago, it was already a big deal. It was used in FreeBSD and everything. After Oracle acquired all that stuff, there was a period when it was taboo, no way for Linux, because of the license. It's not yet the case. So dtrace is like a father of all the tracing utilities. It introduced the approach, some kind of event sources that we may trace and everything. Good news to those who use Oracle Linux. Do you use Oracle Linux, Karen? Is that dtrace is already there. They are like merged with Red Hat and put dtrace all over the kernel. Bad news for everybody else is while the software itself is already GPL and it can be merged, you can do that. I tried to merge this recent dtrace probes all over the full stack from the kernel to recent Fedora. It took half a day, failed, and it was then I realized that whenever Fedora updates, whenever I get new kernel, I have to start anew. So my message about dtrace is simple. While there are a lot of dtrace programs, while the approaches are great and should be studied, in production, in real life case on Linux, we should not and may not rely on dtrace unless you are an Oracle customer who runs Oracle Linux. So forget it. Another thing, yep.
I don't know, in CentOS 7.3, I'm going to build what it builds dtrace probes in, well, it belongs.
Ideas of dtrace, while we were not able to use dtrace in Linux.
I mean dtrace probes inside the source.
Yes, they exist. So the language, the same macros were re-implemented in frame of system tab, and they exist. What I probably missed on that slide, that in case of MariaDB, at least default builds, how I do them, they do not enable dtrace. Fedora, for example, does enable dtrace. So we have that static probes in, for example, 10.3.18 binaries provided by Fedora. In my case, we do not have that on MariaDB options. What's worse for you long term is that if you are also caring not only about MariaDB but Oracle do not provide probes in 8.0. So they already choose their way, and it's far from dtrace, even though they provide dtrace. anything, who killed that, was it a manual shutdown, was it a kill signal, if it's a kill signal, where it was coming from. Recently, there are at least error log entries explaining that if it was normal shutdown, then it was from a specific user, it's written down. And, several years ago, it was not the case. So people successfully, including myself, used system tab on Ubuntu to trace specifically which process sends us a signal. So system tab was useful. It was a great profiler, but it crashes. Not only because it was badly implemented, there is one problem with the way it was implemented. So your system tab programs that looked like dtrace programs were converted, compiled into a kernel module. So that kernel module was loaded into the kernel. And with minor checks, how safe is it? So as you have a full-featured programming language at your fingertips, you could write all kind of wrong stuff, and it could crash a kernel. That's the last thing you want in production. So that your instrumentation crashes the entire set. Just kill MySQL just attach DDB, generate core. It's much lightweight and reasonable. So again, my message is simple. Forget at the moment about system tab. These two tools at the same time had provided a useful framework for collecting stuff. So by profiling and collecting stuff, I mean executing something or doing something when some event happens. All the events you may care about in Linux system may be split into 4 categories. Kernel events, so system calls, or application system, user space events. That's one direction. Another direction, if they are already in the code, are they hard-coded? Had they required manual work of developers of kernel or application system? Adding dtrace probe requires changing the code. So if it was not there, then it's not for you. It's not present. Or it's fully dynamic. So are you able to change the code on the fly? So from this point of view, there are 4 kinds of event sources. Kernel probe, it's dynamic changing of the code in the kernel. Kernel trace point, it's dtrace kind of trace point already present in the code when it was compiled. User probes, that's what specifically I care about, something that you can add to your application code on the fly when you need it, independently of whether developers even had in mind any possible usage of this kind. So you do not care. They write their stuff, you write your stuff, and you can merge it into a running binary on the fly. And user lands statically defined trace points, it's what dtrace introduced. So one way is to have event sources. Okay, you can add something to generate the events. Another way is to how to work with them. Basic foundation was put in kernel 2.6 with ftrace framework. That was created initially for the kernel itself. So it was, at some stage, kernel developers understood that they cannot rely on, building debug kernels, trying to reproduce test case, and then getting all the profiling information they need. They needed something else. They needed to be implemented in such a way that it doesn't affect performance when it wasn't used. So you can find in the internet how it was implemented, but basically the idea was like that. In the beginning of every function, there was inserted an instruction that by default is no op. Instead of that no op, you could dynamically, via the linker, introduce another instruction that eventually was calling your probe code, some code that is introduced there. And at the same time, you could replace it. So there were different approaches. One simple is to call a function that can do nothing, or do something. It was found out that it's too complex, it adds too much overhead. So they invented a bit smarter thing that was then tested and made up to work on multiple CPU environments. You need your CPUs understanding your code in the same way. So it ended up with interrupt 3 introduced there a breakpoint. So instead of no op, you introduce a breakpoint, and on breakpoint the CPUs have to sync. And then after that breakpoint, you either call your probe code or something else. So, and the probes were added with ftrace that we are working in a really simple way. We are a file system. What can be easier than working with text files in a Linux system? So that was the very first interface. You were mounting initially debug.fs or later trace.fs somewhere under sys kernel debug or sys kernel debug trace, depending on the version. And when you mount it, you have a set of files, text files. You can read from these files to get your tracing results or variable traces, or you can write to these files. Similar as you work with prods, for example, file system. So you can write to the files to enable specific trace point, tracing in general, and whatever. So it's a really simple interface. Based on this interface, different front ends were added with time. In kernel 2.6, perf profiler with perf events was introduced as actually a front end to this basic tracing mechanism. Later front ends include, but are not limited to, so-called BCC tools and BPF trace that are specifically a point in my talk. So still right now, even in CentOS 6, that's what I tried myself, in all reasonably old kernels that you may find in production, you need nothing else but ftrace itself to actually add a dynamic user probes to any, not every other line of the code. With perf you can see to which lines of the code you can add it, but to any instruction. So you can squeeze your breakpoint in between instructions. You cannot squeeze it in the middle of assembly instruction. If you try to do that, everything will fail on execution because you will get a wrong command. But in between instructions, you can do that. So it's done as simple as follows. The example is in this case from Fedora core, but it works equally well on Ubuntu, and with minor changes to the names. Debug.fs versus mount. For the mount command, it works on CentOS 6 as well. So you have a number of files in the tracing directory, and you can create a probe. Here the probe was created with perf, honestly, and you can see. So the probe says that you have to attach to the MySQL binary coming from this specific file. It was a binary built by myself. And the probe is for instruction with that address. From the beginning of the address space of this binary. And this instruction, this probe got a name. It's a user probe, hence P. Probe MySQL is like a class. If you would not put that part of the name, it would be probe dash and your binary base name. DC is the name of the probe, and that's it. There is some other probe as well. Called DC1, okay, I have two probes at the same, at different addresses, whatever. So this is how it looks like. This line was added by perf, but you can add it manually as well. So is it easy to work with these two manually? Yes, it is, and next slide shows it. So how it was done actually? It was actually a writing the text of the probe. In this case, the probe was for the same address. The address is the beginning of dispatch command function. How I got it? I got it easily by objdump. So I found a function that mangled name looks like dispatch command. It does not understand, the interface does not understand C++ directly. It needs what is written in the object file. Then I found this address, and at this address it's an entry into a function. You have some syntax, it's quite simple and explained in the kernel sources itself. That allows you not only to just trace, to register the fact that you were there at a specific time, but you can parse the arguments. So in my case, in my probe, what I did, I found out how the arguments are passed to the function. They are passed via registers. First 6 arguments are passed via registers. You should know which register they are. Even though it was a 64-bit, it's just a third argument. Yeah.
If you're talking about production of debug builds, then
it's not about debug builds. It's
so load addresses are pretty much always randomized now. How do you get that?
There is one step that I skipped here. You can, in general, you can even attach to a prod file system to the memory image of the running process.
So you go down on the memory image?
Yep. But here, that was done on a live system with Fedora 10.3.18. So all I needed is, well, in some cases, if it was a trace point in the library, you need to know base address. But that's just the address I got. I tried, and it worked.
So it automatically deducts like base address.
Yeah. So I got it from, in this case, I got it from objdump for this specific process. And no matter how times dry, you get the same address. Yeah. Even before that, I got it from the perf probe added via a bit safer mechanism. There are cases when you have to guess about that address. If you want to trace not the entry to the function, then you have to add more and more things. But you actually can put the probe on multiple lines probed inside the function. So every other line of the code can become a probe this way, this simple way. So what I'm doing there, I'm printing as a string the content of the register with shift 0 from the beginning of that memory address. So it's a third parameter. Third parameter is a query text, so this, the example that goes through all this presentation is related to capturing the queries. It's not a big deal, but you can really get the text of the query. It gets more complicated if your parameters are not simple strings but structures. You would have to compute somehow for ftrace, you will have to do it manually, the offset, the shift from the beginning. It's, I'm not saying it's easy. I picked up an easy example, but it already, it's more complicated for MySQL, for example, because they use structures at that stage already.
Just a question on this example here. So here you add a row from to this command.
Yep.
Yeah.
Then I enable tracing of specific probe and enable tracing in general.
So when you put that probe, like there's no reference on any PID in there. So can you...
There is a reference to PID. So what you have in square brackets is a reference to a C. MySQL D dash is actually a part, unfortunately not a full PID. For short PID, it will be literally PID.
So basically my question is, when you add those probe,
it applies to all binaries starting from these files.
So you can put the probe even before MySQL D is running?
Oh, yes.
And you can also put the probe even if MySQL D is already running?
Yes, it was always running in this case.
So like it talks about like the linker, the random, I don't remember exactly the randomized.
Okay, so these offset methods. It's more complicated in case of S or dynamically awarded libraries, because it's like yet another case. So as with usual with my FOSDEM and all other presentations, I want more details of how I did it. They are presented in the blog post. Interesting part here is time. So for each probe added via ftrace, you have a timestamp, and it's quite detailed. So you have a timed events, automatic things that you have to enable separately, for example, with performance schema, if you want just counters or if you want to know the time of each and every occasion. So it works, but it's a bit complicated. So you have to find out where to attach the probe. What's worse? In case of probe, you have a static printout of what you put. What if it's good for getting the raw data? It's good for getting. You can, with different traces, you can get stack trace at the moment when the probe executed and many other things. So it's low level and it's a bit complicated to work with, but the worst part is this. What if you do not need this raw data, but you need aggregation? What if you want to have smart probes, some code that checks this raw data, summarize something, like collapses stacks, for example, as PTPNP does? So for this you need something else. And here, when so-called eBPF framework was added to the later kernels for this specific reason. Initially, the name comes from E, extended B, parity PF packet filter. It's FreeBSD's firewall. So for that, for process complex firewall stateful rules, they invented a way, implemented, and it was then borrowed by Linux actually, so that you have to write a code, some program, but it should be safe because it runs in kernel's context. So it should be a virtual machine. So they added an LLVM virtual machine, added a way API that would generate the code for this machine. You write your probe code using this API. It's translated into a bytecode. Some checks may apply for safety that you do not have a deadline, for example. But even if checks fail, in worst case what you will have your virtual machine fail, but not the kernel that runs it at the point. So for smarter, more complicated probe codes, this was later invented. In practice, you can use the full power of this stuff starting from kernel 4.9. There is some history behind that, so in which kernel version what was added. 4.9 added a way to use eBPF tools as a real profiler as well. So the last thing that was added is a probe that runs every time you want, so with whatever frequency per second, like real profiler. So now you have everything, you have in perf, now you have everything that you have in ftrace directly, but with the ability to define a program. And for the API that was initially in C, there were later bindings added for Python for simplicity, in C++ and whatever. And after that, so-called BCC tools appeared. So these are already Python implementations that you can get for typical stuff. So do not bother much about specific tools that I reviewed. Typically it's just lists dtrace probes, if there are any. This is how one of the ways to find out if dtrace is compiled in or not. Another interesting tool that was created by Brandon Gregg specifically for MySQL, QSlower. It does what my previous probe do, but relies on a dtrace probe at the beginning of the query and at the end, so it logs the queries and measures execution time for them. It's like a slow query log on the fly that can be enabled, and unlike the real slow query log, there are no writes to disk until you need them. So you control how much information you need, or you can actually try to go much farther. But still, it's, getting queries is at your fingertips. So it's not so much to type, you just run the tool that you can build. There are some build problems, but it works. So the last line, the last item is for myself, and I did it. So the entire point of using these tools versus perf or ftrace directly versus attaching GDB at some intervals is to measure the impact. How much you slow down your execution. So and that's what I try to show, at least for a simple example. Another useful tool that actually does again what my manual attempts to work with the ftrace did is called trace. It allows you to attach user probe to the beginning or to the return of any function using the same syntax more or less for the probe. And a bit different syntax for printing the arguments. You do not rely on the way how arguments are passed. You do not need to know which registers are used for which parameter. You can refer to them by name. Or in simple cases, when you do not even have a symbolic information, you refer to them as argument 1, 2, 3, starting from 1. So I'm printing argument number 3 as string, and it's actually a query that was executed. Okay, the format is a bit different. Again, you have a non-mangled correct process ID. That's what you cared about. Unlike ftrace, it accepts arbitrary lengths. It does not print just four last digits. You have thread ID, so you can distinguish queries coming from different threads. You have the binary and whatever. So the format is quite tunable. Again, I have a blog post explaining how this can be used and given even more. So on top of that, what we have recently, specifically in my Fedora 29 and everywhere starting from kernel 4.9, people decided that while for programmers, for serious teams like Facebook has, writing Python or C code of BCC tools using the raw API gives the most flexibility. For quick usage of people like me, Brandon Gregg himself, who need to get a quick pick of what happens, out of nothing, without any previous idea of what we are looking for, just try this or that. We need something better than writing in Python code that can be complicated, but still more flexible than just attaching the probe and getting simple printouts. So they invented another tool called bpftrace. The code for bpftrace look like the AWK code. So you have a probe, you have a template that the probe that actually was captured should match. And then you have a simple program without loops. So it's condition, action, probe, condition, action, done. And this program is read once. Each template is matched. Each condition, if it's satisfied, leads to execution of the probe text. And when we ended up with this program, we are done. So that it's safe in the sense that it doesn't have loops.
So, I don't know if you remember, Valerie, when we were hunting this bug in MariaDB where like there was a full table scan instead of an index. So MongoDB provided me with a debug build to like see what was going on. Basically, with all this, like
you would not need a debug build.
We could have done this without the debug build by putting the right trace and basically running on something without stopping production, like just connecting on this.
Without need to wait and without need for Monty to bother to add printouts and
do compile and so.
The thing is that the debug build I also get the optimizer choices and why and
theoretically you can get this as well. It depends on you. It would be a simple single probe. You may need more.
But also, like for me, when we were hunting that in production, that also means that I don't have to restart MariaDB.
You can do much.
Yeah, the debug build you could provide a field that says right probes and print verify.
Yes. So that's what I'm defending. And unlike with ftrace, that's really complicated for a normal human being for trying more than once. With this stuff, it gets easier. Moreover, I put a comment to my blog from Fedora maintainer of BPF trace, who told, for example, BPF trace does not understand C++ names, so you need to use manual names. In Fedora 32, that's already fixed. So people are working on that. This is a live stuff that everybody cares about. And as it's used, for example, in companies like Netflix, where Brandon Gregg is from, or a company like Facebook, it's already tested at scale that all of us might just dream about. It's far beyond what we will see in practice in the majority of cases. And it's also already applied from day one. It was applied to database. So Brandon Gregg, in every second example, uses either PostgreSQL or MySQL because that's what people use in real life. And it's also applicable to running in containers. It's about my knowledge and my experience because I don't do containers so far like I but it works. So
basically what you're telling is, as a support person, when like now instead of like telling me, hey, attach GDB at a breakpoint to this,
run this.
Like, run this PDF.
There is some common problem for both approaches, but it's way easier just run a tool that you can in Fedora, for example, you can get it from repository, but it does not look like a hack. It looks like a normal use to work in the system. So there is a bit different syntax for the probes. A trace point is a static probe, uprobe is the beginning of the function.
Can you get the return value of the function?
Yes, uret probe. That would be.
For example, here we get the file that's open. I would also like to have a file number.
Yes, you need just another syntax for a probe. There is a separate name for a probe, uret probe in case of, and that would be, I don't remember, maybe trace point or trace pointer in case of static probe. So yes, by default, it's supposed that you put probe at the beginning of the function and at the end, and you can get the exit status. So you may find out if it fails or not. So I have, well, I just highlight the fact that for me it looks like AWK. So what you have here, there is a probe. Let me give you a better example of what I did. That's a thing that worked only on Fedora and not worked on Ubuntu because it's a recent edition. So I've created a simple replacement for PTPMP with BPF trace, lightweight one. So what I need to do, I have a profile probe that probes at the given frequency. It can be not just 99 Hz, it can be 99,000 and still reasonable. So I will not miss any stack trace, unlike with GDB. So for that, I have a template. If common is MySQL, I can get execution of every process in the system, but it will be a bit more overhead. If I'm interested only in MySQL, I say, please print me, that's my stuff for my whatever reason. I would like to split stack traces one from the other, so I put a comment of a kind, print me a user stack in per format. By default, format is doesn't include address and it's presented below, BPF trace old format. So print me user stack. At that same moment I can ask print me kernel stack. Well, in the kernel line at the moment. I can split them, and that's what Brandon Greg's tools do. So that's what I get. And put it aggregated. In this case, it's just user stack, they are not aggregated, but in reality, you can have an associative array with a stack trace as an index, and number of times this specific stack trace was noticed as a value. And that's PTPMP already implemented in one command line.
Yeah, without the 5 seconds.
Without the 5 seconds or whatever. So now the final test that I did for this presentation specifically and never before, I tried 3 things. First, apply PTPNP. While the sysbench test was running, I picked up a simple one, OTP point select, so that I get on my outdated hardware and get some numbers that I would share to see. It was pretty much default MariaDB. So perf, record, and BPF trace profiling with associative arrays that I used. So I've counted how many times already inside the probe. I have not written each and every step, but I aggregated them inside the probe. So what I got as a result, PTPNP I just got the output on screen already aggregated, that was cool. But slow. In perf I got 5.4 something megabytes written of the file that then I had to process. And in case of aggregated BPF trace probe, I've got 2 times, not 2 times, more or less 2 times smaller file of already aggregated stacks. Performance drop, that was I care about. So first number is what I got without any profile. With PTPNP attached for 60 seconds. The test was running for 60 seconds. I got 56%, so notable like 40% performance drop while PTPNP is running because it's attaching GDB and deattaching everything, and it could just hang, it happened sometimes with GDB. Then with perf, I've got 98%. That's what you can get in CentOS 6 2.6 kernel anytime. So the same tracing capabilities with only a fraction of performance. And finally with BPF trace, because you already aggregated that during you process the probe, I've ended up with like 99, almost 100% of performance with 12 threads, so I have more threads than CPUs. It's non-scientific experience, non-scientific experiment. It's one time, like one test, but well, you can repeat it multiple times. The trend is clear. So it's a lightweight replacement for PTPNP, and actually there is an interesting branch created by Ranger, by Alexei Stroganov from Percona, PTPNP, where you can put any tool, you put QuickStack and some other tools to get stacks faster to get with GDB. So I expect that next step for me would be to put BPF trace there, because to do your aggregation, and you will see it in blog post, I have to get that aggregation AWK program from PTPNP to collapse the stacks, for example, for perf. Here I would like to see the same advances, same options to process stack traces as PTPNP. So the last but not the least, if I have time, that stuff was already presented at FOSDEM yesterday, flame graphs. So there is nothing unique in flame graphs. They were used for quite a long time. What they are good for? From perf, for example, you collected the data. You can get, if you collected with -J option, you can get whole stacks. You can present that as a huge tree of where the time was spent. For any complex process, you will get the output many pages long that is hard to interpret. So your idea in general is to find the problematic point. So what flame graphs brought to us is a way for any tool, it does not matter which tool is used to collect stack traces. So they can be aggregated and presented in a way that you may find interesting or useful. So you will not find it useful from this slide. Let me try to do it alive. So these files should be viewed in the browser, SVG files. Yeah, it's really more interesting. So what you have here, I'm not sure how is it visible. The principles were explained at FOSDEM. In any case, you have boxes. So the wider the box is, the more samples with this frame were noticed during your profiling. At the top there, you can find current frames, so what was executed at the moment when we took the profile. And you can actually click on this stuff. Too big, okay, let me click here. Can find out all the underlying step trace and see how much time was spent on this specific stuff. So it's a quick way to view, not always quick, okay. Search and everything. It's a quick way to understand what are the most popular step traces and how we ended up. Yep.
What is the grade line done? Something could be resolved?
Yes. When we have just numbers, it was done for Fedora coming for MySQL coming from Fedora. Some symbolic information was missing. Some symbolic information for libraries were missing. Some kernel symbolic information were missing. So yes, one of the problems with this stuff that for it to be really useful, you need to have symbolic information for everything. If it's missing, you will get just numbers that you can figure out what they're about, but it's not that fun. So I would just suggest you to check sometime these links from this slide to find out different types of flame graph exist. For example, you can trace the memory allocation, trace mallocs, who allocated memory, how often and stuff, who did disk I/O, why were stopped executing on CPU, so that's off CPU flame graphs, what you are waiting for, and all that. So it can be applied to any profiler tools. There are special scripts, different kind of applications because different format of stacks for perf, for BPF trace, for BCC tools, for dtrace, for whatever. So it's a bigger thing flame graphs than just covering Linux. And you can get it using these tools. So I'm going to the end of this presentation. What are the problems with this approach? So why it's not widely used yet? First of all, for a typical DBA, you need sudo and even root access. If you don't have it, neither ftrace, no perf, no GDB helps you. So that's why in some cases all you have is performance schema or other show commands. So you need them. The program that is traced, the code is changed on the fly. So if you at the same time will attach GDB, you will get interrupt tree breakpoint, and then the code does not match the image, so you cannot debug the program while it's traced in a reasonable way. How to make probes less intrusive? Okay, use BPF trace. It's already trying to do the best to not allow you to do bad things.
About actually, in the root access or doing access through MySQL, for GDB you don't need.
It depends on operating system. For example, on Ubuntu, even for MySQL D that I built myself, for perf to attach I need sudo access. So there is a file to tweak for that, but it really depends on distribution. In some distributions, to get access to ftrace, to ftrace events, you still need root for sudo access. It does not matter that you own the process that you are tracing.
Well, I expect for kernel stuff you probably might need to watch it for GDB if you don't need it.
So I have not studied it really carefully. What I noted that in some cases for ftrace I even have to do sudo su to get real root because probably of ARM. So even do as far as that. So simple sudo was not enough without coming to more details. So there are problems like everything should be ideally built with frame pointers, you need debugging for and everything. The most important problems are at the end, I think. So surely you have to install more tools. In case of MariaDB, for many customers, tools like GDB and perf is a part of a tool chain that we demand them to install eventually. These are new tools. Nobody has this installed. My experience with Fedora 29, quite new at the moment when I started, now it's already out of support, was that you have to recompile BCC tools and BPF trace from current source code for it to work, because the package was outdated. Kernel changed, API for these probes changed, and every attempt to use BPF trace just crashed, even though it worked in October, for example. So all happened in the meantime with some updates, but no update for BPF trace RPM. So you might not be able even to rely on normal package. for this stuff. That's a problem.
So when you compile it, figure out the kernel that you're using.
Yes, when I provided all the details for current kernel headers and everything, it compiled it worked perfectly after all, and it allowed me to complete this talk in general, because I was stuck in the moment. How comes? It worked in October and now it doesn't work. It crashes. That's a bad thing. That's it. Is it a crazy idea in general to ask DBAs to use yet another set of tools? Maybe, but I think it is not. There are way more crazy people who does this with Oracle RDBMS. So they do not have access to source code and still find some value in creating dynamic props out of experimenting and still finding good stuff, because they can trace everything in the kernel and then come up with some addresses that every time are there, and then make some conclusions, maybe go to the binary, find out what happens in Oracle RDBMS inside. We have full access to the source code. There is no excuse not to do this stuff when it allows to get a low impact profile. The last but not the least, I would like to thank MariaDB Foundation and Anna Videnius personally for being making a table for me to go here, because it's a developer conference for corporation. I'm not a developer, it wouldn't happen otherwise. If you have questions, I'm here for you. If you have nothing better to do, in all problems with MariaDB, please report a bug. It's my usual message for Peter Zaitsev reported a bug. It was already found that for select from information schema in a DB mutex, we do not have a name. We do not have a name, not only in 10.4, but in 10.3.7, there will be a bug. So when you're at the conference, you may be speaking about good and great stuff, you can still find and report a bug. Somehow it wasn't reported. It shows that even basic SQL level tools, access to profiling information, are not widely used, so nobody cared to see them until recently. I hope that would not be the case for DPF trace and other related. Thank you. If you have more questions.
Unfortunately, I was still on laptop iOS 7. Is there anything on this I can still use? So
you can use ftrace and perf starting from.
Yeah, but I think also perf.
Yeah, it would be perf. It would be perf with bigger impact than this recent tools. Yeah. But still you can add dynamic probes. The main idea that you can add any probe you need. You can pick up any variable at any specific step in any function, in an extreme case.
But then you have to use this ftrace way of
yes, you have to calculate the address. Or with the help of perf, there are perf commands. Unfortunately, that talk was not accepted anywhere, but it's in my blog post. I had, in case of Oracle, I had to pick up the query from some line in the middle of the function, where it was already copied properly to a local variable. So that works. But basically it ends up calculating proper offset from the beginning of the function. Or from the beginning of the actually executable image. In worst case, your probe will crash. It happens often, but nothing else would suffer. So if you did something wrong, you will see it immediately.
Superb, really, really good. So we have another exciting next talk. We'll jump around a bit in the program. It's Vlad Bogolin about the BuildBot, recent changes, and look forward.
So hi, I'm Vlad. Sorry for the change, but in order to catch my flight later today, since we are a little bit late, I made the switch with Vicentiu. So today I'm going to talk about the new billboard for the MariaDB server that was developed by the foundation. I will explain you the things behind the new billboard and how do we ensure that the MariaDB server is properly tested and ready to be used. Firstly, I will talk briefly about why do we need continuous integration and the benefits of having continuous integration. Then I will dig into the more specifics of the new billboard for the MariaDB server. Sorry. So as you are probably familiar, the coding process for the MariaDB server involves pushing frequently code changes to the main repository. So regularly integrated changes to the source code, to the main source code. The ideal case would be to have tests running after each change. In this scenario where tests are run after each change, we can ensure that it would be a lower risk of test failure, which is something that's involved with each push. And also tests can be run on multiple platforms, ensuring that one change on a particular platform does not affect other platforms. In this way, developers would have immediate or fast loop feedback on their work, and they can act accordingly if something goes wrong. Least but not least, automatic testing and continuous integration can deal automatic packaging. This is something that is planned to be done in the future. In this way, we can have binaries and packages automatically being built by the billboard and made available to the end user so that they can be downloaded. However, the challenges that occur with continuous integrations are strictly related to hardware availability. There are two types of needed hardware. One would be regarding the diversity of architectures and platforms that are tested. In order to be able to test on different platforms, you need different machines that are from that platform. And there are also limitations regarding on how many machines and how powerful these machines need to be in order to have successfully running the system, so that all developers get the response as soon as possible, since nobody wants to wait a couple of days to see if the test passed or not. Now I'm going to briefly tell you how testing is done for the MariaDB server and then dig into the specifics of the new billboard. Basically, MariaDB server testing is done using the MySQL test run toolkit, which mainly involves running queries and seeing if the expected result is the one that you actually get. In this way, there are checked both that the server has the right behavior, but also that the data is consistent. So now let's dig into the billboard. So the new continuous integration framework is based on the latest version of the billboard framework. Everything starts from the main GitHub repository. There's a build master that continuously looks for changes in this repository, and when a change occurs, it runs the building phase on different workers. So basically, a worker is a specific environment that is running on a physical machine. The build master looks for changes in the repository and then schedules the necessary commands that are run on the worker. If something goes wrong, there can be different notification hooks that alert someone. So the main keywords that are related to build-bot are changes. This is pretty clear. The build master, as I've told you, is the process that looks for changes, and if a change in the source code is detected, it schedules a build on a worker. The worker defines the actual build environment, and this is run on a physical machine. These are strongly tied together, since an environment may depend on the architecture of the physical machine, but also on the installed packages and the operating system. And finally, the build is the actual configuration of the MariaDB server that it's tested. This involves everything from what flags are passed on the compile phase to what plugins are enabled and so on. The new build-bot uses Docker. Basically, each worker is a running instance of Docker that can be remotely accessed. Different from the old configuration, there isn't a build-bot process working all the time, waiting from commands on the worker machines. It's just Docker running. When a change is detected, the build master builds a Docker image that defines the environment, and then runs that Docker image and tells the new process that is started to do the actual building of the MariaDB server.
Question?
Yes.
Can one download the Docker image for build so I can repeat it on my home machine?
We have Docker files, so you can build it on your own machine at this point.
So I mean, if I look at the local files and it fails, I can basically download the Docker image.
Yeah, exactly.
You don't know the Docker.
So everything is everything is set up with Docker files, and this provides an easy way of recreating a particular testing environment. This is one of the main benefits. And the other one is that on a new physical machine that may act as a worker, there are no build-bot configuration needed. So basically, you just have Docker, you just need Docker running and to be remotely accessed, and then just configure the build master to know that there's a new worker, and it can automatically start building on that worker.
But you cannot do installation tests with Docker.
Everything that's installed is defined in the Docker file, which is the first step when the build process starts. So basically,
that's not what I'm saying. I'm saying there's build step, there are tests that do different tests. You cannot do a test of how the MariaDB installs inside Docker. Because you cannot have system data.
Without system
you need either images, virtual machines, or this old one thing, so the new one.
Of course, system is the only thing that's a bit different.
Why does it Docker support system D?
Because it doesn't.
Because you need to access the OS.
Okay.
There's a variation of Docker carried around with a better that can do system D. Because I was to talk about that before, which I didn't do that. But maybe this can be overall.
yeah, in order to have system D, there has to be something else.
So can you also combine the build, but you also have virtual machines like that?
Yes. The current version supports both virtual machines and Docker, so this is something that it can be done. The challenge that appears here is that Docker has to be accessed remotely, so proper security needs to be assured. We use TLS authentication to be sure that nobody can access the Docker if we don't want. Another thing that it's done for the build-bot are some customization of the main dashboards. For example, the default templates do not show any message regarding the status of the build. It basically shows the build number, which is not that significant, so we change it to have the status of the build shown directly on the main dashboards. This is the interface, basically a screenshot of the interface of the buildbot.mariadb.org. You can access it and look at it and see if you have any suggestions on how to make it more developer friendly. MariaDB function donated by our sponsors. And regarding the various operating systems, we have Debian, Ubuntu, CentOS, Red Hat, Enterprise Linux, One, Fedora, OpenSUSE, and Windows.
You run also Windows in the Docker?
Yes, you can run Windows in Docker, but the host needs to be to run Windows.
Sorry?
The host machine also needs to run Windows. Also, another thing that is possible with the new Buildbot is...
one stupid question. Is it possible to use mine? Before or after coding? Apparently do it.
Another thing that's available in the new framework is the ability to run tests for pull requests, and this can be integrated with GitHub, so the results of the test appear directly on GitHub, so all the developers can benefit from viewing the test, the status of the test, without leaving the GitHub interface. This is useful since maybe not everyone knows about the specific URL of the Buildbot. And in the future, there needs to be done more configuration, build configuration, operating system, and maybe even platforms need to be added. Another thing that we want to do are gated branches, in the sense that you cannot push on the master branches without having the test passing. Automatic packaging and cross-reference tool that will allow to search in the Buildbot to search for failures and other.
Is there any progress on any of these? So what's the state of it?
So the first one, it can be done. We have to see what configurations are needed, and there might be some hardware issues that need to be resolved. Since adding more configuration would increase the number of builds, and we do not have enough machines. Gated branches can be switched on. There's one known issue that I'm aware of, which makes the builds fail from time to time, but doesn't occur that often. The testing process is killed by C pipe. And on the cross-reference tool, I've started working, and regarding automatic packaging is something that needs to be done later.
What is automatic packaging?
Well, like automatically uploading the created packages somewhere so that they can be downloaded.
Oh, okay, then download it.
Yeah. So if you have any questions.
Actually, downloading of log files and everything else, is it like in all the digital files?
I don't exactly know.
Yes, the point was actually to make the new Buildbots build the final packages which we release
really want to have a copy of the log detector. Because I did a microtest / margin. You want to have a copy of that. So storing the last 100 of those would be really good.
Yep.
It can be quite big if you have cores, but in the worst case, remove the cores. But still, otherwise, the kind of qualified. That's not that big.
Yep. Any other questions? Then thank you.
Next or only 2 hours later?
My suggestion is that everybody picks up tea and coffee at the please and return direct to the seat. We already had extra time to chat when we were waiting for lunch in vain, so we do continue with the next presentation directly. It's not you, but if you need, come here. It's Vincenzo or you. No, okay, you can go. Go ahead.
I just need to connect the internet. Sorry, password.
Relay 2018.
Let me first.
Thank you.
Okay, are you ready for S3 and Monty? So then please sit down. Okay, yeah.
I'm giving about 8 talks a year.
I am. I'll take a photo.
I have to sit because I have a clicker button.
Come on, someone.
No, but at least I'm close to the microphone. So. And I will of course give the slides to Ian after my talk so he can put it up on the website immediately. But you get the newest one because I was still editing today. Okay, but let's start. As usual with my storing things on S3, that means several attempts and nobody knows ever reach production. It's kind of production ready because it's already used by some customers in production. But about S3, it's a horrible idea to store database on S3. And but the customer really wanted that, and we tried to satisfy customers, so I did it. So S3 briefly is a way to store files easily. You get the boot, it's not fast for a database. And for example, move doesn't exist. You have a move command, ABS will basically delete and read copy, which of course makes it hard for database to want to change blocks. And for how many have used S3 here? Okay, for those who doesn't know, it kind of looks like a file system, but it isn't. So basically, when you buy it, you get a bucket, and that's kind of your base address at some web page with slashes, and then you have commands that can kind of show you what exists in a kind of a directory, but it isn't. So this is a 3 storage engine in MariaDB. So the customer that needed this, they had seems to be a standard issue with big organizations that you get the machine and that's what you have. And these customers had a standard machine is 32 gig of RAM, 2 terabytes of disk, and that's it. I know some of the branches needed much more data. So they come up with an idea that maybe we can access the data to S3, so they contacted me and asked me, so can you do some storage that they can do on S3? I said, I don't want to do something, can you do update? But for archive purposes, read only that you can store things archiving, and then you can use partitions to handle lots of those. That I can do. And that's really what we agreed I should do. And this also the S3 that is actually more secure storage and much cheaper. Yes?
Why do you optionally compress? Why do you even keep non-compressed data on S3? It doesn't have any use case. Having non-compressed data on S3.
Let's say I wanted it to work first.
Okay.
And it's much easier to test.
Yeah. I just asked about
I have only implemented zip, but it's trivial to add any other. Yeah, because we have it already in the source code. Not much, yes. To be against S3 for testing, S3 is slow. So the customer, when I was visiting the last time, said that, oh, this S3 engine is so fast. Why can't you make MariaDB as fast? So apparently I did something right. So we support all, because this, the format is based on the area storage engine, so we support all key compressions, indexes, everything that the area supports automatically, which is kind of nice. And it has its own page cache, so it doesn't conflict with anything else. It's in 10.5, but some of our customers who wanted S3 are using earlier versions of MariaDB, so we have backported it to MariaDB Enterprise Server. And that actually I think is a good thing between using the community and the enterprise is that if you use the latest, you get the same thing, but customers doesn't like to upgrade. So we provide more features for the customers without upgrading. And this is something that the community doesn't want because most people don't want us to go and do big changes in already stable releases. Okay, so how to use this? You have a table, you want to use it in S3, you do another table and it's in S3. Okay, what talk is that? Kind of. But internally, I first create the area table with row formats page and without transactions because I wanted to have it as compact as possible. And because I created from the start, there's no gaps, everything, all pages are lined up perfectly, which actually makes caching much faster. That's one of the reasons why this is so fast. I also created two. If you have lots of area tables, you can copy all of those to S3 and copy them back, and you can delete things in S3. So for somebody who wants to do batches and testings, this is, or want to convert terabytes without affecting the server, you can just do it. So the new options for that table that is related for S3, you have each table can has its own block size. If you don't put anything, we put 4 meg because the testing we have done on some customers, 4 meg seems to give you the best performance. It's also the reason that the S3 storage is so fast that when we read one block, then we have to read everything around it. And so we always read 4 meg at a time. So and if you do, for example, read next, all those pages already in memory. And with compression, with zip, you already get about 70% compression. We are probably going to look at adding something else also, but I don't think that for indexes, especially the savings, so big. So good. Quick setting out that table, you also have to add some configurations. You have to add how to connect to your S3 or bucket or whatever they call it. So you have to just add some basically 5 parameters, and also if you want the buffer that all the tables are shared. So, going to use S3 because it's a storage engine that if you have a master and slaves, you have S3 engine and use different storage, in which case everything just works. The application works, no problem. The master will just send queries over. But the hard part was getting this to work, because you want to have S3 as an archive. Then all organizations can potentially access the same storage, which is fine except when you add replication. Because if you do a change in the first master of the for S3, for example, you rename all the table to add things, you don't want that to be repeated in the next one, because it's already done. So here's all the things, tricks I had to change in the server when it comes to S3. So I did a quick check to see that this is the distributed engine, and in that case, the slaves will ignore anything that has to do with S3. So from the slave point of view, the S3 is more or less as what is it called? Not black box table, but like black hole table. Except that as soon as we do something, we delete everything on the slave, because if we do an alter table, we have an FRM file on the slave that will be out of date. You always remove it because the slave or the user is using this discovery. So always when you have a table that doesn't exist, it checks it. If it exists in S3, it takes the FRM file from the S3 and put it locally so it knows about it. So I have to delete that if something changes.
That's optional. You can still have like two different pages, one on the master and one on the slave, and then have a copy.
I mean, you have two setups. You have this one or this one. So which one are you talking about?
No, so you want to just specify which setup you want.
Yeah. So you have to configure when you use the server which one you are going to use, because the server needs to know about it. So and on the master there is one problem, that if you have a table on S3 that is shared, and now we are converting it back to InnoDB, the slave can't repeat that, because when the slave tries to run that, the slave notes that there's nothing in S3. Will instead basically do if you ever have a shared storage, if you don't have that, it assumes that no slave is using the same storage, and the only thing that you lose is that when you convert from S3 to local, the bind no longer be bigger. And on the slave, you have to say that if you use the shared storage, you don't do anything with S3, and that's S3 slave ignore updates. That's the only setup you have to think about. So that basically was everything about using S3. If you have any question about using, you can do it now or later. Because now I want to quickly tell you for how this was actually implemented. Because we have some people actually who are developers here. So let's then get a little bit about what I actually had to do. I started by looking at the interface that is kind of the standard interface for using AWS DBA CPP. It was interface using templates or templates. It's relatively how to upload the table. But doing something else is totally horrible, and I think that this is one of the worst C++ code I ever seen. And I kind of reinforces my view that templates is something that you should never use. So I spent basically a week to try to get the simple thing of reading a big block uninterrupted to them, to MariaDB. And after 1 week I kind of concluded that this is horrible, because it also had to take care of the things in binary, not binary, and things are different. All examples was not binary files, and then it was just horrible. And the code was bloated and very, very hard to use. So what we did instead was we had Andy Haskins creating a library based on libcurl who made things easy. And this is LGPL, anybody can use that who wants to use S3. I highly recommend it. This makes life trivially overwrite everything. So you have a list to know what files are where. Then you have get, put, delete. The list we only use to know does this. Actually, we use status to know if a table exists, and when we do discovery to show this table exists, then we use list. But otherwise, you have just put, get, and delete. That's what you want. Much faster and much simpler than anything that Amazon provides by default. And it's basically 3 steps where and because it's really trivial to find out where things are. I choose to basically this. I think an example shows it much better. It's food, and it's kind of own key, and if it's one file, then it's 1, 2, 3, 4, and so on, same thing indexes. The frame is that they're separate, because we use that for discovery, and we also copy that on discovery to your local files so you can easily find them. We treat a different area, it has all information, structure and everything, so it was easier to have it outside. And that's it. So it's really easy format. So to implement this, I wanted to do something that is support all key formats and operations of optimization that the area storage engine supports. But in the end, this is the first commit that basically has everything except replication. And that was 4,000 lines. And just to get the feeling about how to implement this, here you have the different files and the file sizes. And in area, basically had only to change open, because instead of reading from disk, I know I have to read from S3. And then I had to extend the page cache to be able to, and then I read one block, instead of just reading one block from disk, I need to get this big block and put it in the page cache. So, the replication was the hard part. The engine done was actually pretty easy. And here you have almost the whole handler interfaces for implementing the engine. And this kind of shows the power of the handlers. You can do really complex things with very, very little changes. So the create basically handles the internal creation of the area table and then converting it to S3. And write rows was needed, because even if you can't update in the S3 table, during alt that table I need to be able to collect the rows. So that's why I needed to implement write. So I already kind of mentioned these ones. So those took some days to do. The page cache took, Lasagna did that, took a week. And by the way, this also proved that I'm still programming. Because except for the page cache changes and Andrew helped me with the library, I wrote this. So the limitations, I said they are read only, they are for archiving. But because there's no locking provided, so that if one server drops the S3 table, the other ones will just get the reader. The page cache will basically handle it gracefully. You will get an error that then read error or block, and then there's not much you can do about that. And adding information S3 that for every time you open the table, you create a block that will stop the drop from happening while you're working on it. I thought that was too much overhead, so I decided not to do that, at least not in this stage. And if you alter the table and somebody is using that, they'll probably get an error at some point if somebody else is using it. If you're using it for the same server, you're fine. It's only the scenario of multiple servers that the other servers are trying to access it, because in that case there's no locking. Is that currently we have these ABS keys. They are in the configure file. We have only specified ones. I would like to be able to have those different keys per table, so you can have one table on this server, one table on that server. So then Spider Federated X uses a MySQL servers table. I would like to store the keys there. And the customer, of course, wants additions. After everything was agreed, they did know that this is S3, this is right only. S3 is not suitable for database changing because I can't change the block. I can basically delete the block and add the block. Anybody who is sharing that will be very, very confused. So, but they still want to be able to do updates in archive things. So I was talking with Sergey and he came up with an idea that we can do some updating, but only if one user is doing that. And so I probably have to do that at some point. But this is mostly for the idea that we have, let's say you have transactions per month, and you have 1 month here, and then after 1 month you get some transactions that you want to have added to this partition table because you store things per month. So there will be a way that you can open that and add data. It will not be as nice a structure that is now, but it still will work. It will be faster than converting the table to InnoDB, do the changes and convert back. That of course works. But that's it. I hear this amazing silence.
There's no plans of making it completely fail-safe or reads in replication streams. That's some.
Sorry.
It's a limitation of if you do a drop table, something like that, that it will just fail if it's a concurrent read on the slave or something like that. That's not
You will not fail on the slave. I mean, these two scenarios works perfect.
You had something that.
This is just what it does internal.
Yeah, but if you do anything on the master, then on the slave, there might be some issues.
Yeah, so in this scenario, if the left one drops the table, the other slave will, if they are using it, they will get an error in the middle.
And that's a limitation if you just decided to.
The customers haven't seen that as important because they are mostly interested in kind of this case. This case what I provided to them for free. And what you can always do is that when you drop something and you basically, I mean, if you drop a table that is shared by everyone, that means that the table is not important for anybody else. Well, yeah, Eric.
I understand that they did this work for existing customers. My question is, do you see this as being the kind of solution that will see a growth in adoption? I ask because I don't see that I would use it, but I don't have visibility.
Let's say this, are you ever planning to use a database in the cloud? Are you ever planning to pay for storage? This one, all your old data that you have, you should use in this one because the storage is much cheaper in S3 than a local disk, about 1/3, and you also win 70% of the storage on top of that. So it's 10 times the saving in storage. I know that Booking.com, your former company, doesn't have any big databases, have no problem with storage. But there are other customers who may have an issue.
Thank you.
Before SD Engine was announced, I was at Oslo last year, and there were people trying to do this sort of thing and struggled a lot, and this would solve lots of their problems.
Okay, so it's something that you see a broad interest.
And the best part is, there's so little code that is actually used. Anybody can go and hack and improve it. This is nowhere says something that is hackable. I mean, 4,000 lines.
So obviously it's read-only right now, but you said that it's going to be added support for doing updates.
I want to be able to provide batch updates from one user, just to be able to fill it up.
So once updates become available, do you see this as like a valid use case to make use of S3's replication across region boundaries? Because one of the nice things is if it's very fast, it reads. And
it's extremely fast.
And S3 is handling replication for you. It will allow you to have read-only regions very easily, potentially.
I wouldn't for sharing things across boundaries with this read-only, yes. The updates, I mean, they will work with replication, but Yeah, but I mean it will work. But as I said, I don't recommend S3 for updatable databases. It will work, but
just curious.
Yeah.
Do you mix S3 and Maria in different partitions in the same table?
Ooh, that's a good question.
I don't think so, but in theory it should be possible because they have exactly all. The partition basic requires that all tables has the same physical structure and physical properties, and in theory they have all identical except the fact that this is not updatable. And they actually have a notion of non-updatables. So if you do a partition where you ensure that no inserts are coming to the S3 tables, it should work.
Okay, that was the sound of silence again, so now let's have the chance to continue.
Okay, we are running a bit behind schedule, so I will try to make my presentation brief. So the reason why I suggested this talk is that MySQL 8.0 now has introduced roles. Actually, they have had roles for a while now in 8.0. And I think it's a good time to actually compare the two, see how they're different. So who here knew about roles before having them read about it here first? Okay, so everybody else did not know about roles at all. Okay. So a bit about myself. I am a software developer for the MariaDB Foundation, and one of my first contributions to MariaDB was the roles feature back in 2013. And we released it in 10.0, which is now an end-of-life release, but we basically had roles for a long time now. Compared to Postgres, we were far behind. Postgres first had roles in 2005. I'm not quite sure when the SQL standard defined the exact roles, but it seems that Postgres is following most of the syntax there. We added roles in 10.0 2013. We tried to follow the SQL standard as much as possible. And MySQL also added them in 2016. And most of the implementations are compatible, but MySQL has a couple of extensions that we need to be careful of. Yes?
Was any customer asking for this feature, or do you just want to fulfill the standard?
This was a Google Summer of Code project back in 2013. Maybe Sergey can say where it started from.
I would say it was not asking a few feature requests from users to the show. And it seemed like a reasonably isolated project.
From my experience, customers don't explicitly ask about roles, but they ask about how to solve business problem which roles perfectly fit. Like, the privileged ones.
Okay, so I'm going to go through a basic use case, and we'll see which ones might be useful for a generic customer. So in essence, roles are kind of like a group in a Unix environment. They can own objects or have access to database objects, be it tables, databases, procedures, functions. They can also gain privilege to modify certain aspects of the server, such as creating or dropping users. And with the caveat that this is not true for all databases, you cannot log in with a role. MySQL does allow you to log in with a role. And the superpower of roles is that they can inherit from other roles. So you can make a very nice role hierarchy, and you only grant users the specific roles that they need. So in essence, they simplify privilege granting and revoking. And instead of having to manage a bunch of users to make sure they have the same privilege all the time, all you have to do is update the role that was granted to all of them. Because roles can be activated and deactivated during a session, it's very easy to implement the least privilege principle, in that you're not running around as root, touching every file in the system. From a practical perspective, there's no performance penalty, or very, very little. I'm going to go into details on this, both from our control, also work just as well with just one table of transactions, and we have a couple of users. We have a user that deals with reporting, so only selecting stuff in the database. I'm going to call her Rachel. We have another script that always puts data into the database, so an import robot. We have a developer, Dave, and our admin, Alex. I'm going to grant the appropriate privileges to everybody. So report gets select, import gets insert, development gets all the rights for the data warehouse database as well as the staging one. And admin, on top of that, gets create user privileges on the server. And he's able to grant other users the ability to create other users. Notice the bottom 4 lines here. This is the syntax for granting roles to users. So instead of granting to some user with an on clause, you don't have it. You just have a role name and a user, or the username, or the role name and the other role name. And for those of you who are much more visually inclined, this is the layout of our grants. So we have 4 databases on top. The MySQL one is the metadata database. It's not the server name, it's just the database name. We have the 4 roles: report, import, dev, and admin, and our users at the bottom. Yes?
You should pass that MySQL database below our case when you declare.
Yes, that would be clever. The arrows represent rights on those objects. So report has select privilege on data warehouse, import as well, dev and admin have everything. What I don't like about this is there's lots of redundancy. I need to define the same privileges for dev and admin, and just one special extra privilege for the admin. And we can do better than this, because, like I've said, we can create role hierarchies. We can eliminate duplicate grants, and we do this because roles propagate privileges. Notice here, I've highlighted in red the duplicate grants for the admin role. We can substitute those by granting development to admin. So now we only have to maintain development for the basic insert, update, delete, drop table privileges, and admin only has to specifically specify create user. So instead of this, with these 2 extra arrows here, we move it from admin. Admin gets all the rights that dev has. plus some extra ones. Make sense? All right. A few caveats with role hierarchies. If you have a cycle, it basically means that everybody in the cycle gets all the privileges of everybody else, because you could make a loop around and gather all the privileges. MariaDB specifically disallows cycles. I don't recall if the standard enforced that or not. It just didn't make sense for us to allow hierarchies and then basically collapse them with a cycle enabled. So if you do have a cycle defined in your MySQL database, the way we store the role graph, we will just ignore the last edge that creates a cycle. If you try to create the last edge with the grant role, we will return an error. MySQL will allow it, but that means that you might end up giving rights to roles that you do not expect to give rights to. So you need to be very careful here. And there is no way to disallow this sort of behavior in MySQL.
Second question.
Yes.
Just to check what you asked. So it says that no cycles for all authorizations are allowed.
Okay, so we followed standard in this case. Now, you might be a bit worried that supporting this sort of hierarchy might have a performance penalty. And we took care not to have to go through the full chain of roles to get all the privileges. The moment we encounter this sort of chain, we cache the privileges till we get to the topmost role. Our strategy is different compared to MySQL, but in the end it leads to the same result. So we compute them whenever you do a grant. Actually, I think. Okay, so next slide is going to go into more details. So we compute effective privileges when we load the graph from disk, and we store it in memory, whilst MySQL does not compute the effective privileges until they are needed once. And then they are stored in a hash table with the key is the user that has those roles and the ones that are active. So if something were to change, this hash gets invalidated and you would have to pay this penalty again. But it's not, it should mostly mean that the first check for MySQL is going to be slower, but the other ones are going to be just as fast as MariaDB. And they will have no performance penalty during grants, although having a slow grant statement, regardless of how slow it is, it's an infrequent operation most of the time, so it's not something that you're going to be worried about. So in the end, I think both implementations are good enough to be used in production, although I kind of prefer ours because it never introduces a performance penalty during selects.
But if you have thousands of neighbors and colleagues, you can't have all of them.
You can have all grants, yes.
But if you have, let's say, 10 million grants for a user, of course that will get because you have to check it.
You have to check it anyway. I didn't understand the question.
Yeah, but each check has a performance implication. Checks are not free, especially even if you go to a hash or something. How do you store the hash? How do you store the hash?
Okay, so the performance penalty that roles incur is one extra check. Like it's this, it's two times the cost for checks. And this is the same for both MariaDB and MySQL. And so let's talk about the least privilege principle. And here's an interesting scenario. So Dave, the developer, has a tricky bug to debug. He needs a clone of some tables to investigate, so he gets to work. He sets his role to Data's data warehouse development. He creates his copy of his table and starts work. After a long day, he's very tired and he finally finishes. He wants to clean up. So he tries to clean up. But he did it on the wrong database. Because he did have the rights to drop tables from the production database, because that's what the role gave him. So all this could have been avoided because you could split these privileged lock into safe and dangerous ones. Like I said, there's no need to run around as root all the time. You just enable rights when you're really, really certain you need to do something on those production databases. And this sort of thing would not be possible unless you were to change users so that you get a different set of privileges. But you can do this with roles. One other difference between MySQL and MariaDB is that MySQL allows enabling multiple roles. This does provide some strange semantics. We can obtain the same result by creating an extra role that covers all the previous ones. So if you just...
This also directly contradicts the standard, and the standard has a concept of current role. So you can create for a procedure defining a current role. And how this will work if you have multiple roles at once, that's completely not clear.
Yeah, I'm not entirely sure how they... I didn't test that, I wanted to, but I didn't get enough time to do that. But their current role is basically a string.
Yeah, I thought they don't allow defining current role. Last time I checked, I think.
For stored procedures, probably, yeah. Well, other than that, there's no really too different of a behavior. What I didn't mention it here, but actually, so MySQL also implements mandatory roles, which are roles that are always active. An easy way to have a blanket grant for all users all the time. Perhaps that's useful. It's not in the standard, so I don't have any more information here. But it is something that MySQL supports. And the standard also specifies a couple of information schema tables. We have the first two, so enabled roles and applicable roles. Enabled roles, MySQL implements them differently, and it's not according to standard. So if you enable 10 roles in MySQL, you only get those 10 roles. But the standard says you should also list the roles that were granted to those roles. And MySQL does not do that. We only allow one role to be enabled according to standard, but we will also print the roles that were granted to that role. Applicable roles have the same behavior. It's the roles that you could enable. And MySQL 8019 very recently added these extra ones for easier introspection to what the user can do with what roles.
And they are fully standard and we don't have them.
Yes, this is according to standard. Actually, they have modified them slightly. They have extra columns, for example. Well, applicable roles is mandatory, which is not in the standard.
But we don't have that.
So the last ones we could also add, since it's part of the standard. So overall comparison, both databases do allow role-based access control, no problem. From the practical perspective, they should be pretty much compatible as long as you stay away from non-standard extensions. And other than that, make sure that you disallow logging in as a role in MySQL if you want to disallow that. And well, pretty much I think they are at this point feature complete, more or less. Right. So I will not be here if we are sponsors one way or another. So this is their slide, thanking them for that. So that's all I have. So if you have any questions, please go ahead. So I was very, very confusing.
Very clear.
Just one super question. It's possible to create one more like